Someone asked what I'm drinking tonight. The answer is it's a Modelo. They're making this Modelo Chelada now. I don't know if you've ever had a Chelada, but it's like a Colombian drink. It's just a light beer with salt and lime in it, like a lot of lime and a lot of salt. It's really good. It's like the margarita of beers. If you like margaritas and you like beers, you'll
Plugging that in felt weird. Hopefully my audio is okay. Alright, I'm gonna put all the RC car stuff into a bin. The lights on. Boom, there we go. Hey, welcome. How's everybody doing?
I think that's gonna be my new look.
Hey, don't ask.
Everything.
Alright, let's see here. Isolate the battery contacts so they don't do anything while this thing lives. Let's take the oscope out of here. I gotta put everything onto the breadboard so I can test it. I did some reading about the structures and the clocks and all the settings that I should probably put in. I think I need clock A. Like the clock register A, because there's two clock registers, because that's not confusing at all. There's two clock registers, and I think I need one of them to be active in order to function properly. I think I need the other one to actually have settings in it for it to do anything. We're gonna clear the board, and I'm gonna take apart the a CPAP machine though, so none of this stuff is relevant right now. 4N6 Paloozer? What are you talking about, bread? What are you talking about, bread? What's that supposed to be? What's that for? Identify yourself. Get all these parts in here. All these parts. I still need to do the gluing for the carbon fiber rods for this thing to fix them. Those will go with the programmers. Although, you know what? I'll put them in here for now because I'll want to just work out of this bin at the other desk. So I can play with the microcontroller a little bit. Because, I don't know. I don't know what the fuck's wrong with this thing. Like, I mean, maybe we just didn't register all the clocks properly. You know, that's all I can really come up with. Alright, just neatening up the desk so we can actually do a disassembly. Got a medical product today, so it's probably going to be pretty well assembled. This is an exercise that teaches me and you how stuff is put together. We can emulate that and try to make better stuff when we do go to make stuff. Part and parcel of why I do it. Also lets me show off my reverse engineering skills a little bit. little bit. I cannot for the life of me find a high-rose DF13 connector. I'm getting a little angry. I'm always getting a little angry. It's my secret. But I can't find this housing. I don't know what I'm gonna do, because I based part of the motor controller design on this connector. I was like, man, I can put the servo on this little tiny high-rose connector. But I don't know if it's right there, Chad. I don't know if it's gonna work. Check it out. So I got the high-rose. I think I already pulled one up over here, didn't I? No, this is all Arduino stuff. It's all microcontroller stuff. Here it is. High-rose DF13, right? Proteus. How's it going? We got a little nub on one side. We got a little keyway right here, right? This is the high-rose DF13. So let me see. Let me pull up a data sheet because that'll have exact dimensions. DF13 series catalog. Like, all right, DF13. Oh, what is this music doing? What's this music doing? Let's go to something a little bit more backgroundy. Absorption area. Yeah, DF13. It's a tiny little plug. Pretty neat. Probably doesn't exactly carry the amount of amps that I need it to. It's good enough. Dimensionally, we're looking at this guy right here. We got our A, B, and C dimensions. I was wondering if, because I can't find this thing anywhere. I looked everywhere, man. It's like that one listing that I had open. Where did that go? Let's close some of the stuff that's not necessary today. We're not doing microcontrollers today. I didn't expect to do microcontrollers yesterday, but it took up all day. Damn it. This guy right here. Visit site. Ready? Temporarily out of stock. Yeah, right. Temporarily, my ass. They're just gone. Nobody has them. High-rose DF13 3-pin. Three-position, 3-pin. Go to Google Shopping as a Hail Mary. Nobody has, like, the header. Everybody's willing to sell me these things. Nobody has the plug. Where's the plug? Show me the plug. Why do you do this to me? I guess the larger version of these are used in like drones and stuff like that. Like they're not uncommon. The 3-position one though, I can't find dick. And I used it as a cornerstone of the design of the motor controller. I'm pretty pissed off about that. So anyway, I was looking around and I found the high-rose DF14. One more number in the sequence of connector series. The thing about the DF14 though, no, they're too small to be 3D printable. That's way too small. I mean, maybe if I had a resin printer, I could do something a little closer, but 3-pin DF14 is like an abomination. What the hell? Why is it so wide? What happened to you, DF14? Do you want to discuss it? Or should we just back away slowly? But anyway, the DF14 DigiKey has tons of these little guys. They're 50 cents each. Are you kidding me? But I'm not sure that this fits. They made me download it. Oh god. Drawing. No, stop making me download the PDF. Flip it. Flip it. Flip it. Okay. So, yeah, the pin pitch is the same, but I'm wondering if the connector itself fits into the housings. Like, it does have a tiny little keyway, but let's see what the height is here. So, 0.155. I need a drawing for... There we go, 0.155. Not even 2.3. Yeah, so they're not interchangeable. God damn it. I don't know what to do. I think I'm just gonna have to wait. Have to wait for my back order. which I have absolutely no idea how long that's going to take. That's really frustrating. Ah, man. Why did I use like a weirdo part? Oh, copyright. Strikes again. Let's put the 3P in here and see how much that hobbles my results. 3 position. It's all that side. I need the other side. I need the housing. Curse you, high rose, and your hard to find for some reason connector. Crimping connector, 3 position. Wait a minute. Is this the right thing? No. Damn it. They said crimping connector. That's not the crimping part. Those are the housings. Or no, those are the male part. The ones that everybody has. Nobody has the other end. How can you have a connector if you can only find one side of it? It doesn't make no sense. Ugh. How are they gleefully selling billions of these things and nobody has any of the other end of it? It's so annoying. DigiKey, what are you doing? Send me my part. Maybe Mauser has it. That's the wrong kind of. That's the wrong.
I'm gonna call it a night here.
The wrong Mauser. Mouser. Talking.
Joining in. Wherever you came from.
Pyros DF13. Boop.
I'm trouble. Dizzy made stem.
I skipped over and he's still talking. He's allowed to talk. It's his stream. All right. So DF13. 3P. Pop.
All right. So a couple more songs, and then
maybe the other part is pre-built into some popular device. Maybe. I wouldn't know. Housings. Housings. How do I tell which one is the plug that I need? 3P. That's DF1. That's not even the right series. I probably need to use their tools in order to narrow it down, huh? DF13 3P. What's the part number for that? Not the DF14. That doesn't fit. DF13. That's not the right thing. They don't give me the part number. I'm going to go to DigiKey. DigiKey will tell me. Is DigiKey's easier? DigiKey. All right, GoDaddy. All right. Probably a multi-million-dollar website. DF13. Bob. Oh, wait, no. I want housings. 27 items. 3 positions. Apply. Ta-da. DF1. DF13. DF13 3S 1.25C is the part number that I'm looking for. Bop, 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 bop. Copy. Go to Mouser. Mouser. Search. Get 1 part. 0 in stock. You can still purchase for back order. On order. 34,000. Factory lead time 28 weeks. What did DigiKey say for the lead time? 0 in stock. I have them on back order with these guys. 27 weeks. What the hell? Yeah, we'll try Newark. Is this an equivalent? $221.22. That's Amphenol, though. It's not even the right part. Didn't even. That's not even what I'm looking for. Let's look at a different part. It's similar design, though. It might be compatible. Maybe not, though. I don't know. What is this thing? Yeah, see, it's only compatible with Amphenol. You know, all these designs are just about the same. I mean, this looks like the connector that I used. But why would that part number come up with a different part number, Newark? Oh, look who suddenly has all these high-rose connectors, huh? Yeah, that's what I thought. I have 3 pages of them. This is a cool jam. I like this a lot. Damn it, they don't seem to have it. Connector housings. And they've only got like 4 pins and up. Damn it. You know, like, I don't know if they don't seem to like, well, they have DF13. Connector housings, this is the same 6. Yeah, so they just don't have it down to 3 pin. This is a 2 position, 30 position, 40 position, 4, 8. I have some of the 4s here. I was wondering if I could just cut a socket off of the 4 and use it for now. I think I'll be able to do that. And then the connector will only really lock in on one side. I think the center pin will be off. There's no center pin. There's side pins on the 4. The 3, I don't know if the 3 position has the center or the side. Yeah, I could probably cut them down. I don't know if this will fit. That would be a huge gamble on whether the Amphenol fits. They're very similar looking. Well, we can look at the dimensions. What's that vertical dimension? It was 1.25. They don't tell you. Thanks, guys. 2.2. That's too big. that's 2.2, and the DF13 is not open right now. Curse you. It's going to make me download it again. Go to my downloads folder. That's the DF14. Don't need those. DF13. Opening is 2.3. So if the other one's 2.2, actually might fit. Hold on. We gotta check other stuff. The wrong one. Drawing. Don't download, bastard. Okay. 2.3. Height from the top of the connector to the keyway, 0.78. I want just like 3D models of all this stuff. They don't tell you. What's the height? What's this? What are you doing to me? 2.2, 3.15, 0.7. They're just withholding information from us. You bastards. They're withholding information. That's illegal. It's actually totally legal. They can do that. But I just want to know whether or not these are moderately compatible. The pitch is the same. Yeah, the pin pitch is the same. So one might be able to cram into the other socket. It would be an unholy matrimony. The high rows are better plastic, but whatever. I would like to know this height to the keyway, and then the length of the keyway would be nice. Because I think these have shorter... Yeah, these have shorter, stockier keyways. So I don't know if it'll fit. I have all this stuff open. I'm going to close all this stuff because I don't care. Yeah, it doesn't look like that keyway is going to fit. I mean, the length of the overall connector, too. It's 3.7. 3.2. Oh, no, that's the height. 4. Yeah. They're very similar. Yeah, 3.7 is not the overall, even. What is the overall? Oh, they don't tell you, and that's nice. Okay, 3.95. Okay, so it's 0.05 millimeters off. That's so very similar. The socket type is going to be different, so the pins might not line up properly. It's like they all copied each other's homework when they built these things. So I don't think it'll be compatible. I think I'm better to just wait for the back order of the high rows, and until then, I guess I can chop up a connector in order to try to make it fit, because I have 4 position high rows, so I can chop off a position. The design of the keyways and stuff is going to be a little bit different, so that's going to mess with me a little bit, but it might work. PG Wipeout, 2nd month. Well, unfortunately, the board is not functional right now, so your name's gonna go on a list. You're on a list. How un-American of me. You're going on a list, and that list is gonna be of subscribers that came in between, and we will randomly shuffle the names and put them up on the board. So nobody's gonna be first. There will be no first, but you will get your name up on the board. Yeah, you made my shit list. That's what you did. Thank you for subbing, though. I really appreciate the 2 months. I don't think I promised you a damn thing. Uh-oh. Oh. Yeah. I like I need the no contact thermometer. 75 degrees in here. I get no cool air. Okay. Yeah. We're good. We're good. God, I've got 2 cardboard containers full of RC cardboard parts. Not a bag. I'm finally able to catch a stream. Hey, yeah, man. Thanks for catching one. Appreciate you. Dust out of the scope screen. Metronomic Live. Probably overdue for a Metro stream at some point. If he goes live, you guys gotta all promise me to watch him, because I've been stealing his mixes. He's the one out there. He's the one out there in the trenches, finding all the good music to play. Find a cool beat with a little flamenco guitar over the top. He's the one with the pickaxe at the record store, getting into the ruins. And we're here like the bourgeois. We're here just scraping off of their effort, benefiting from it for free. This song is awesome. I really like it. I am a sucker for a house beat with a little flamenco guitar on top of it. Keep it nice and easy. Just kidding. I'm like picking RC car stuff out of the scrap pile here. Oh no! This is the copyright one. Never mind. This song's awful and terrible. Somehow it didn't get copyright struck, but man, is it a candidate. That's inspecting the guillotine right there. That's what that is. I was like all right, Friday. What am I doing today? I'm gonna take apart something, just for fun.
Yo, Tom, thanks.
Ah!
Thanks so much.
Who's
for
that?
the raid. I'm losing my voice a little bit, so I'll try. The people whose music.
It's a shame he wasn't around during my stream schedule. My stream schedule. I could have had Metronomic on the stream. I also don't have the second mic pack built up. I need to build up the second mic pack. I don't know how they'll interact with each other when I have 2 people in the shop, but presumably I won't be able to hear, the other person won't be able to hear my voice and I won't be able to hear them. face cam. Get rid of the start soon. So yesterday was a bit of a whirlwind. We tried to get over a microcontroller thing, and it would not have it. I think I know what I need to do. I think it's registering both clocks at the same time, but I've packed up all the RC car stuff and I moved it away. I meant to be doing more mechanical stuff yesterday, like putting screws into stuff and building all of the stuff that we built in CAD. I know it works. It's just I need to, that microcontroller thing just kind of blindsided us. And that was something that we could only discover by starting with a new microcontroller, an unconfigured one, and realizing that some of the stuff in my software wasn't configured quite properly. So I think what it is that a register is just sitting in a state and we need to kick it with a couple bits and then everything will function again. Weird problems. I haven't really put it to paper yet. Reading those data sheets is like really cryptic. And I think if I write stuff down and try to get to the heart of the problem, I can figure out why one PWM output is outputting exactly what it should and the other one isn't doing anything. I think it has to do with the states of the registers. It's just a little confusing to get answers about that kind of stuff. And I think the AppMel software can like simulate it, but I don't have that software. So I'll just figure it out on pen and paper when I'm feeling sober and willing to concentrate on stuff. In the meantime, it is Friday. Fridays are for teardowns. So we're going to take something apart. I want to take apart my old CPAP machine. I was on a CPAP machine for a little while. It was basically it was diagnosed with high red blood cell count. And yeah, we're not playing the game. Teardown fucking stole my terminology. They stole my term. I'm not going to let them have it. They're not allowed to have teardown as a concept. I'm taking it back. Anyway, so CPAP machine. I was diagnosed with high red blood cell count. I didn't know what was causing it. It could be a variety of different things. It could have been bad sleeping, which I think because of my weight it was. Bad sleeping, not getting enough air at night, and so your body has more red blood cells. Meh. But apparently, I don't know, the high iron count that I have has something to do with that. Either way, I don't need the CPAP anymore. It was running on the lowest settings and not really all that beneficial. So I stopped using it. At this point, I probably own this one, and they would have sent me another one. But you know, they like automatically sell you supplies for it. It has a cell phone like transmitter in it. So we're gonna take this thing apart, and there's all kinds of cool stuff in it. This is a Philips CPAP unit. One of the things that I'm primarily interested in though is the motor, because it is a fan. CPAP machine is a constant pressure auto pulmonary or constant pulmonary auto pressure. I forget what order those go in. But either way, what it is designed to do is it keeps you breathing. It bars airway obstructions in your breathing when you're not conscious. So what it's doing is it's pumping air into your nose and then giving you a positive pressure in your lungs at all times. So if you have an obstruction or something like that, it'll kind of fight through it. You can do a variety of things with these machines on. These aren't like full breathing machines. All they're designed to do is help you breathe by giving you a constant supply of good air. And that good air is moisturized and it is heated before it is delivered to you through your nose, which also does all that stuff. Filter, moisturize, preheat. That's what your nose is designed to do. Filter, moisturize, preheat. Also that it can get to your lungs membranes and you know, you get all that wonderful oxygen. But the things you can do with this is you can actually, on a cold night, which we don't have anymore, thanks to the environment, on a cold night, you can pull the covers completely over your head and you don't run out of air. You can just stay under the covers. You don't run out of air. You don't need a breathing hole. You've got an air mask on. The other thing you can do is you can infinite whistle. You can just whistle infinitely because you have a constant supply of just about enough air to whistle. Very strange stuff. But anyway, that's a CPAP. Let me get the thing out. It is disgusting. It has been sitting for, I think, 2 years plus. Maybe 2 years it's been sitting. It's got generations of dust on it from times past. So I'm going to get all this garbage. The Philips Dreamstation. Hold on, there's a power supply for it. Power supply. Okay. Ooh. So over here we go. Take a look at this thing. It's gross. I could probably, let me get a paper towel and some Windex here. I'll wipe it off so it's not totally disgusting. All right, let's take a look at this thing. So, this little wonder basically is as simple as it gets. It has a fan, a reservoir for distilled water, because you don't want, I don't know, you don't want to pour like root beer in it or anything. Oh yeah, it's battery powered. Is it yeah, I think it has batteries, maybe? I don't know, we'll see. Let me get the medical company label off of it. Looks like a 60s vacuum, yeah. Yeah, they're not sticklers for design. Could you technically pour vodka? I guess, you psycho. I don't know why you'd want to. I don't know what that would do for you. Oh, this thing is beyond dusting. This is basically just like a nose thing. A little nose chamber with like a leaky hole in it. And then this is above your head, like a Pikmin. But this thing is disgusting. I need to like submerge this in water to clean it. Ugh. Gross. It's been sitting for several years, like under the bed. So yeah, dusty silicone is not one of my favorite things. Ah, it's like sticky. What the fuck? What the fuck happened to that thing? You basically have a tube over your head. You know, it's not for looking good, it's for breathing good. And for the people that it benefits, it is an extremely beneficial thing. I would be sitting here touting its praise if I needed one. And I only barely do. So I haven't been using it. But yeah, this thing has one task, and that's to pump air into your frickin' body. So what it does is it heats this coil of wire that surrounds the air tube, and then it blows air in and around this little misting cup. So I guess this is either heating or I don't think it's like an ultrasound. I think, yeah, it's just heating. It just heats up the air so that I guess it moistens the air with a little bit of heat and just a bed of water. And then the machine pumps air out here, and then it swirls around this chamber and then goes up and out the tube. Really seen that in horror movies? What? USS Sulaco. What was that from? Are we talking aliens here? But yeah, anyway, so the chamber has a rubber seal on the front end, and it has a rubber seal around the reservoir, and the reservoir just simply holds water in place. That's what gives this unit its shape, I guess. But yeah, it's just pumping air adjacent to water. That was, yeah, that's right, I've heard of it. Okay, so it is aliens. Not alien. Power supply, what do we got? What is your output? It doesn't do medical. Oh, 12 volts at 6 amps. That's a big 12 volt power supply. That's a good one. So yeah, this little guy plugs in here. Then I can turn it on. And I did give this thing a I gave this thing a good chance. You know, I used this for a little while. Oh God, I don't want to know my info. Okay, there's not a whole lot on record here. That's a nice one. Yeah, you know, hey, it was a good unit. I'm gonna take it apart. This thing is very old. This is a medical device. Not for long. Not for long. I don't think I can start this thing up because there's no water or anything in it. It can flex on you. I need to get my sleep study done. Thanks for reminding me. Yeah, they pretty much always find problems. Modem. I can't wait to turn that off. Bluetooth. Yeah, you can have a an application on your phone that lets you know what's going on. But anyway, I'm gonna power this off, possibly for the last time. I don't know if this thing's going back together. So over here, there's a filter. There's a filter. Is that? Oh no, that's just designed that way. It just has like a loose material in it. See, these are the parts that they send you to replace. And one of the parts is a filter that goes in here. So there's a big fuzzy thing on the outside of the filter, which really makes it look like it's full of dust. All your breathing air is going through this. Ugh. Well, all the breathing air that you get through this thing. And then there's also a little SIM card to bring to your appointment. By the way, by now they would have provided me with a new one of these things. So this is So over here is the modem. There we go. Got it. That was easy. That's probably information that we don't want. Cellular WO oximetry DOM. I don't know what the hell. It's got all the serial number info and everything on it, and then it's got this little connector on the back, which I don't know what type of it looks kind of like a what does that look like? Yeah, this is the copium machine. Here, let's try to get. What does that connector look like? SFP? All right, let's see. Yeah, it does kind of look like that, huh? It doesn't have the same pins that are kind of like pushed forward as the SFP. But it is about that. It is, yeah, I think it is. Could I plug this into my router? It's just SFP is, it's got different pins that are emphasized there. 1, 2, 5, 6, 10. It's I mean, it's very, very eerily similar to SFP. So SFP would have put these end pins. Yeah, it's a different length, but I mean, these end pins being doubled up for power and ground or whatever, and then it is eerily similar. This is the modem, yeah. I don't want to show it too close up because I don't want serial numbers and stuff to get out. Let's see if I can get the plastic cover off of it, because it looks like it's a little clamshell plastic cover. I might be able to pop it open. Knowing that this is a medical device, they probably glued, epoxied, or welded these two ends together. What, you mean I could put optical networking stuff into the CPAP machine? Like, yeah, now it can transfer my data super fast. Without interference. This is totally useful, and I do not regret it at all. Let's see here. See if I can pop this thing open in order to get the two halves separate. We can take a look at the modem, because I think that would be interesting. A little cell modem. Looks like it uses snaps. If there's any cables inside of this thing, I've already ruined them. Yeah, it just uses snaps, so I just need to get snaps and glue. There we go. Oh, look at this thing. Hell yeah. There's a lot of electronics in this. Man, they did their darndest to make this thing feel like a cheap little module, but holy crap. Look what we got. A Centurion modem. It's got a lot of stuff going on. That looks like a connection to an antenna, but there is no antenna on this thing. And there's a little conductive pad that has two little like dots. What is that doing? It's not LEDs, is it? No, it's like look, what is this? There's a little conductive thing that goes over to this. And that's where that pad goes, I believe. This guy over here. I don't think that's the, maybe it is the antenna. That does look like the antenna. The antenna coming out of the can right here, surrounded by vias and grounds. Going over, and then it's got the antenna filters, and then it's got the redirect to a surface mount antenna connector. Yep, that is the antenna. If I ever done see one before, that is the antenna connectors. This comes out, the antenna comes out here over through a probably also a capacitor filter, but that can be flopped over to this pad, and you can put an antenna with a connector on it, but otherwise it's going through a little bit of a filter, and it's going up through a spring contact to a box on the side of the unit with two little holes in it. I don't know. I don't know what the hell that's about. What in the world? What in the world is that? Very strange. Very strange. But yeah, that's where the antenna's going, so that's pretty cool. Is Centurion? Yeah, Centurion's one big can. I couldn't remove that unless I spent a long time with hot air. And we've done it before, and we've been relatively underwhelmed by what's underneath these things. It's basically going to be just one big, really complicated chip and maybe a transistor or two. Is it embedded in the plastic? Is that what you guys are saying? So you're saying these cups here are like vias, and somewhere in the plastic there's an RF element? I'm not sure, unless that's what that is. This thing? This band? Yeah, that might be it. This might be the inverted planar F antenna, and it's part of the plastic molding. Well, that's oddly technological for something that is already in a plastic shell. They could have just like put a, hey Broly, thanks for the follow. They could have just put an antenna right here, you psychos. Like, what's wrong with them? They could have just put an antenna in it. Yeah, a little over engineering. We've got an FPGA, spare no expense for medical devices. Let's see, data coming in goes to that big cluster of stuff. Oh no, we got more than 4 layers on this thing. We got more than 4 layers of PCB on this thing. All those data signals coming in and blip. So we got some of it coming around here and getting into the Centurion unit. Who the hell knows how to interface with something like this? This is the 3rd revision that they've had of these things. Yeah, but we got an ARM. It's an ARM, an STM32. The venerable STM32. Man, industry loves these things. So yeah, STM32, got the clock sitting right there for it. Probably external memory, I want to say. Although this could be doing that too. This could be just an I2C memory unit. It's got more than 2 pins running to it though, so it could be voltage regulation, something that big. And then couple transistors, maybe diodes or something. Probably a lot of this stuff is support connections for the modem unit itself. But I'm sure that this thing is brokeraging all the data and figuring out all the stuff that needs to go back and forth. They did a good, though, because you've got a big scary device that's connected from the outside world. They put ferrite beads on each individual incoming line. Even I don't always do that. Ferrite beads are kind of neat. All they are is basically just a piece of ferrous, I want to say iron, but it's not really. It's just like ferrous material that surrounds a wire. And so if there's a very high frequency pulse or noise or whatever on that line, this will resist that change. It'll resist that change in magnetic field by inducing a current and all that fun stuff. Hey, Walrus, how's it going? I mean, basically a ferrite bead is like the surface mount version, the very micro surface mount version of these things. The little RF chokes that you put on stuff. How do you tell the ferrite versus the cap? Situational. A lot of it is just the placement of them. So we've got signals coming in from over here, and their goal is to get to that ARM chip, and in between them are 4 of these things, and there are 4 what look like data pins right here. So I'm saying ferrite. In addition to that, they are the gray color instead of the manila sort of envelope color. So those are my tip-offs, is positioning and then the color of the substrate. And I don't know for certain that that's what they are. Maybe they are capacitors, but I would say that having them in line with whatever signal's coming in, as well as the coloration, the size, and the location, would tip me off to say that those are ferrite beads. What are they labeled as? I don't know if they really get labels. E4, E10, I don't know. Yeah, they don't see these get D, so those might be diodes. All right, so that's the modem. I mean, we could reverse engineer this thing until we're blue in the face, but I don't really think it's going to get us very far. It would be kind of fun, but it's a modem. You power this thing up, it's going to handle getting on whatever network there is. Actually, I wonder if this thing is 3G. That's going to get depreciated, so I don't know if this will function anymore. It doesn't say 3G anywhere on it. It's probably Edge, right? This thing is just for data transmission, though. And I'm sure, you know, you can probably get every iteration of these things, too. Anyway, that's the modem. This thing doesn't need it to function, but it helps it upload data to your healthcare company so that they don't send you supplies when you're not using it, which is my case. When I haven't been using it for over a year, 2 years, 3 years, Jesus Christ. I haven't been using this thing for a long time, and so they don't send it, you know, they don't send you more supplies. Yeah, no SIM card. I guess it's just got an internally programmed SIM. All right, let's get the reservoir out of here, and let's see if we can get into the device itself. We'll see what we got. Now, remember, the stuff that I'm interested in, well, first of all, I'm not interested in doxing the company, which seems to be a thing that this is, like, adamant to do. What the hell? So the entire reservoir is a removable component. Everything that all this stuff over here is dishwasher safe. I guess this one is not. Yeah, it's Verizon 3G or an embedded SIM. Look at that. It's got 3 attachment points where there's like a little lever that lifts up, and then the whole thing just comes off. Where do you get off? Okay, so all the management of air in this thing. There's another door right here for this little tube. So I guess everywhere that air is hitting, you can clean out. And look at this, the whole fan unit is this big. Put this in your spacesuit cosplay. You just need a big 12-volt battery for it. You can get yourself some air. Okay, I'm trying to get this thing to unclip. There's a clip on this. How's that coming out? Oh, there we go. Okay, this is just a tube that goes between things. So this is the seal for the reservoir on this side, and then on this side it seals to this unit with that tube. And then I guess you can remove this for cleaning. They didn't tell me about that when I went through all the training. Looks like there's one little like air baffle inside just to keep flow going correctly. I bet you they have all kinds of really complicated CAD of how this thing directs air around. Okay, well then, I guess all the rubber seals or silicon seals are replaceable too. IDX, what are you talking about? Yeah, so that goes right there, and it just seals this unit to everything else. I wonder if they have different reservoirs that you can get or something like that. Yeah, I need a big boy reservoir. All right, so we've entered the zone of no connectors. There's an intake here and an output here, and somewhere in between, we're gonna find a large enough fan. I thought the fan was gonna be much larger on this unit. I really did. But we need to find the fasteners for this thing, and so they've hidden them. My first inclination is to go under the label. I should probably cover over... I gotta cover over a bunch of markings on the bottom here. Hold on, give me 1 sec, chat. I'm gonna get the gaffer's tape out, just so that the medical company and the... Any cell phone data is gonna be censored from your doxing eyes. Everything else we know about this thing is that it's from Philips Electronics and that it's a medical device. I know you guys are smart. I know. You guys don't gotta tell me. All right. Turbine, yeah, it's like a squirrel cage blower. So the first place to look on a device like this, you guys are like the kids watching Blue's Clues, shouting out. So there is a dollop underneath. Sergazi, thank you for following. There is a, I can feel a little. I'm gonna ban people if they're too dumb. Okay, couple things about finding screws on a device like this. There's a couple different places that they could be hidden. One of the places that I always look for is under the labels. They'll put a bunch of stuff under the labels, and so what I'll do, yeah, aggressive rubbing, is I'll poke at the label and I'll figure out where there's a divot. Now there's only one divot right here. There's only one divot right here. I don't see symmetrical divots, but it is rather centralized. That could be the injection point of the plastic for this piece of molding. So this bottom shell could have an injection point right there, and they put the label over it. It's kind of a mean trick because a lot of the times, if you don't have screws under the feet, which you don't, you freaking idiots, you will sometimes have screws under the labels. Yeah, I guess you could use a magnet. That would be an interesting way to go about it. I don't do that. See, there are no feet under the labels, you idiots. So yeah, anyway. There might be a screw here. I don't think that's gonna bust the whole thing open. We have hidden screws under the doors. So they're really using every resource that they have in order to keep the consumer from seeing a screw. We got two up here in the front. Two in front. That looks like a breakaway shell. Possibly this one right here. So let's cut around this one right here. I don't think it has a Zigbee. It's not a Zigbee. Compiles with section 21. Okay. And then there's a potential for the front panel to have stuff that pops off in order to get at the screws, but I don't know if that's going to be the case here. I think maybe if I get those two and this one, that might be enough to hold this whole thing together. It's a little up close though. So let me see. I'm going to get a knife. I'm going to cut FTL. Yeah, I don't know what. ETL classified. It's not FTL, it's ETL. That's right there. So slice across it and see if it's a screw or a plastic port. I think it's a plastic port. We have a plumber coming in today that's going to be checking stuff out down here. The best thing that we could tell him was that I had a web conference. It's like, what do you say? You know, get my hair cut. And they're like, so what do you do? I'm like, spreadsheets. Yeah, spreadsheets. Like, I don't know what I do. What do you mean, what do I do? I don't do a thing. All right, so that was indeed a plastic injection, but why are you beeping at me? Drama queen. Serial killer? Hey, you know, I'm a serial killer. More insulin. More insulin. An input output explorer. What? That's how you get funny looks. All right, so we know 2 screws, so let's get at them. Might as well. We saw 2 screws during our adventure, during which you guys were mewling about how the thing was held together that you were wrong about. So just plastic is holding these things on. Just basically push down on one end, get the other one out of there. I'm hoping as a medical device, this thing is easier to take apart, but they're probably using every trick in the book. One thing about medical devices, sometimes they're very cheaply built, and sometimes they're very expertly built. I guess we're going to see good stuff. Yeah, educator, I guess, would be. But then they're like, whoa, where do you teach? I'm like, on a site for, like, hot tub streams. Hot tub streams and morning zoo DJ hosts. Okay, that's not cooperating. These are some plastic screws. Look at these mofos. Look at that thing. Look at that thing. That's a hell of a screw. I'm hot tub. Yeah, right? I don't know. The marking on the foam is one thing. I just want a better extension for it. I want a solid extension for it. I like this kit. I like this kit a lot, and I'm happy to finally have a screwdriver bit collection that I chose. I have the larger version of this kit, but I don't really ever need the larger version of this kit. This is pretty much, so far anyway, this is pretty much everything that I need. I will evaluate later on whether or not I feel as if I need more bits in my life. So I'm still kind of formulating opinions on that. It's not like I review screwdriver kits, but I know people listen to what I say when I have commentary on them. There appears to be like another fastener in the back of this thing. Somewhere back here. Unless that part just snaps together, which is kind of what it looks like. Yeah, kind of just looks like the back is like snapped together. Happy Friday to you too, Smith Clay. Thank you for the 10 months. Your name is going on a list. You're on a list. You're on a list. And then it will be randomly chosen. Well, it'll be randomly ordered. Sensirion. So that's how it's doing the pressure measurement right up in the front too. Interesting. Okay, so let's reveal the electronics. Reveal the reveal the electronic. Reveal. Hello. There's yeah, something's holding it back. Something's holding it back. There is another fastener among us. Something got to give. Something's got to give. Not a door. Okay. What do you guys think? Screw under here? Nah. That's an LED. That's not a screw. More screws. It does feel like more screws, but you know, I've already been under these. There's nothing under there. That would have been a good spot for them to put it. If they had one. They don't. Let's check. I think I've checked all of them right now. Yeah, I've checked all of them. That's not a screw. There's no screws here. Everything is smooth. Smooth as our brains, chat. Those look like clips back here. Is it just really, I mean, it could just be clipped together back there. That seems like a little bit of a... No, there's just it's a plastic welded thing for the knob. It's not. And I don't have access to that. Well, I think I can pull this out. Yeah. I need to unseat the connector though. Hold on. If I was gonna do like a spaceman cosplay, I would definitely be wanting to save this thing and use it as my air supply. Although you'd have to figure out how that water is gonna stay in here. It's important to moisturize the air because otherwise you'll be drying yourself out. Although if you turn this into a positive pressure like face mask unit, maybe you don't need the water reservoir. I don't know if it would function in that regard. It would probably yell at you, think you're dying, because your air delivery is weird. Because this thing monitors your respiratory rate, because it does that with air pressure. As you breathe out, you're going to be hitting up against this air and creating higher pressure. Where are the snaps? I will find you and unsnap you. What is holding you? It's really in there. Like, that's copium reservoir. Oh, what's the bet for? I can't see it anymore. Hold on. All I can see is predicted yes. Wow, great. Great streamer tools there. That's really nice of you to do there, Twitch. It doesn't even, like, I have no information about what the bet is. It might be, I don't know, I'm on my creator dashboard. It should have some kind of a window. Tell me something about whatever the bet was. Gotta know what I'm up against. Okay, so it really feels like there's another screw on this, and I ain't seeing no screws. There's no clear, unless this whole panel pops out, but there's like a gap overlap over here, so I don't think that'll just pop out. And there really is no evidence of there being any type of fastener back here. What the hell? Things are weird. Oh, bet that it was only 2 screws and it would flop open? Yeah, okay. Cool. That's a good one. Can we see, like, deep into the thing? I don't see nothing. I don't, like, it feels like there are screws, but it also feels like there are snaps. I don't want to break it. It does kind of feel like I'm gonna break it. Slide forward. Of course, Schmide would say slide. No, it doesn't seem to be sliding. Not getting a lot of sliding mechanics here. It's gonna move in such a way that it's just gonna fucking cut me. Like, I'm gonna have to deal with arterial blood on Twitch. I think arterial blood is not toss. I think it's intentional blood draw. But if it's arterial, I think it probably gets by the rules. So I should be okay in that regard. I'm dumbfounded, actually, because it seems like there should be an obvious connector somewhere around here. An obvious screw or something. I see posts for the screws, but the movement, there's too much movement. I see posts like right here. Relax. Holes in the top corners of the recesses. Yeah, that was for the door. That's for the little doors that cover the sides. All right. Chat's discovered their favorite toy again. What about the ends of these? Yeah, wait a minute. Ha! Got him. That was annoying. I saw just a little thing at the end of that clip. I thought that clip hole was for the yeah, I don't know. How strict do you want to be about what you set off for, right? Depends on how strict you want to be about it. All right. I'm gonna unplug that soon because there's a plumber coming here. I don't think he wants to hear that. God damn! All right, it's gone. It's gone. Sorry, guys. I got somebody coming down to look at the water pressure, and I don't want a shit ton of farts coming out of this room because I'm supposed to be on a web conference. Sorry, it's my rules, my fart box. You guys make your own fart box and put it on your stream, and then we'll see whether or not you keep it active the whole time. If you got a plumber coming over. All right, so that revealed pretty much everything we need to see now. There are screws that are holding this thing into the bottom piece, of this. So 1 and 2, I can't get to them. One of them's under the circuit board. So I'm gonna, yeah, we corked it. So I'm going to get rid of the screws that'll release the PCB, and we'll see what other features we've got in this thing. There's some cool stuff. Definitely some cool sensors going on about this whole business here. I see one pressure monitor, I see another pressure sensor, and I see... That's not even a pressure sensor. I don't even know what that is. Weird one. It's like a capacitance. Might be a flow meter. Part number and everything. Very small circuit board for what is a pretty, I don't know, it's a pretty compact object, actually. They did a good job building this. If it's a plumber, he's going to laugh at the random farts. Yeah, but he hasn't agreed to be on camera, and I'm supposed to be in a web conference, and I don't know. I'm just not going to deal with... I'm not going to deal with somebody coming in here curious and then having to brief them on what they're allowed to say and not say, how they're allowed to, you know, how they interact with what's going on, how many people are watching them. So, walk a mile in my shoes, chat. All right, 2 connectors, 3-pin, many-pin connector. I'm going to assume, well, no, because we've got the 6-pin connector here. So one of these, let's see, from the 6 pins, I mean, some of them are going to the heater. It's 2 heaters, actually. 6 pins, 2 heaters, and maybe I think there's a flow gauge at the end of this. So we got a flow gauge at the end of the pipe. We have 2 heaters. So that's 6 pins, easily. Why is my hand so dry? Jesus Christ. Like an old man hand. Yeah, we got a lot of cool stuff going on this board. A lot of cool stuff and a lot of different pressure sensors. Whatever the hell this thing is. I'm kind of interested in this thing. Might be an optical flow meter, but it's got its own little cutout on the board. Pretty cool. So we'll have to check that out. These are fairly common in like engine ECUs and stuff like that. Like Mega Squirt uses one. Pretty cool. Little dual, they basically do a difference in pressure between the 2 lines. You get like atmosphere and then whatever pressure's present inside of the thing. This is looking a little bit more complicated than I thought it would be. And we've got intake air coming in over here. Fan, output. So let's pull this thing out and take a look at it too. There's like a giant brass bolt sitting in the middle of this thing. That's the microphone for all the CPAP machines. So many jokes about China, and I haven't even mentioned them at all yet. I don't know, you guys. That's a little weird. Let's see. Can I get this out as one piece? It looks like it's, is it attached in there? Oh, no, never mind. The whole thing just fell out. And then how's that thing? Oh, what the fuck? Okay, hold on. I gotta get this thing, the little power connector out, which is a completely separate thing. Usually these components would be sitting off of a circuit board. That would give it a little bit of anchorage. help it hold in there. How do I get this out? I don't think it has to do with this piece. No, that's not gonna do it. Ow. I mean, I guess I could just pry it out. Yeah, it looks like it's a pry it out kind of deal. So just get the tweezers under it. There you go. All right. More plastic shell crap. Power in. Oh my God, this whole connector is power in. That whole connector is power in. What the hell? Well, we know that there's no more, there is not a, what do you call it? There's no battery in this thing. There we go. That's what I was looking for. No battery in this thing. It looks like we've got a squirrel cage blower motor that's basically contained within this thing. There is a flow meter over here and a pressure sensor over here. Intake, I don't know. Is that like a bypass or something? There's no other control. I mean, we've got three wires going to the motor, so it's likely a three-phase motor. We'll have to look for the transistors that control the motor. That thing just clips on, creates a seal. There's my power. This thing's crazy. This thing was a lot easier to take apart than I thought it would be. Don't see a label on the motor, so we'll have to figure out which it is. And it's got a ferrite on it, so a lot of mitigation towards what do you call it? RF noise. I mean, there's a cell phone like right here, so it's a good idea to have ferrites on stuff. Let's see what it's doing with the air, though. What are you doing with all my air? Turn this into a smoke filtering unit. I don't think I can reverse the flow on it, though. It doesn't really work that way, so I can't use the tube as an air sucker. I was hoping. But maybe we can just salvage the motor. If it's quiet enough and it does seem to move enough air, what I just did nothing. There we go. Look at that guy. And actually, it's on a lot of shock mounts, so it might just be a DC motor. Wow, what the hell? It's just like a little vacuum motor. So what is happening here? We've got two chambers. There's a heat sink in between the chambers, it looks like. Is that for a sensor, or is that just... It's just air direction. What the fuck? Huh. Yeah, that's just to cause turbulence for this pressure sensor here. All right, so air's coming in from this chamber right here, right? Air comes in here, it's directed, sensed, maybe possibly a flow sensor. We'll take a look at what part that is. That's the one that gets that little cutout in the circuit board. It does have a buzzer, but that's not what we're looking at. We're looking over here, where we've got this little component that's cut out onto the circuit board. It's got its own little area right here, right? So that might be possibly optical flow. I'm not sure. We'll investigate that. We've got these two pieces that are getting a difference between the two chambers. So air comes in here, flows into this chamber, into the second chamber, and we've got a sensor on both sides. So we've got a pressure sensor on both sides. That's what this component is, with the two tube things on it. And then we have a grid right here. There's a lot of foam, a lot of foam. The foam there for noise? Or is that to do something with the air? Or is that, I don't think it's filtering dust. Because then there's an open path from, who the fuck is calling me? Oh, they let the phone ring once. That's surely a legitimate call. So yeah, air comes in here, goes around the bend. What the fucking hell? Oh, it's got the first 6 digits of my phone number. Of course it's legitimate. All those people from Delaware calling me. Yeah, I'm sure. I would love to hear about my car's extended warranty. Frickin' bastards. Can we just bomb whoever's making these phone calls already? Could that be a good usage of our military budget? Anyway, so yeah, this airflow in this reservoir. Coming in here, coming around here, getting a pressure sensor here. Don't know what that's about. I mean, I guess that's just handling intake air, right? So intake air has this like set of flat fins that it has to get through, right? If you're making those calls, might be jerking off. I might be doing something else. There. It's not the best view in the world, but you guys can see it here. It's just a set of plastic fins. A set of plastic fins, no sensors on it. The only sensor on it is a pressure sensor that straddles the plastic fins. So air is just casually flowing by here. It's been restricted a little bit. So it's going to be flowing a little bit faster than it's coming in through the filter. But that pressure difference through a set of fins, I don't know. I'm not that kind of engineer. I don't know exactly what that's for. But that's kind of an interesting thing. Yeah, it's okay. It is a measured amount of air. We know that. And the fins are there to create probably a little bit of turbulence. And so we're going to see a pressure difference across these two. So we're going to see if the fan is sucking more than it's blowing. I don't know, man. But anyway. Differential pressure against a known restriction gives you a flow rate. Creates a measured amount of resistance to airflow. If it's a pinhole, it's referred to as an orifice plate. Does it look like a pinhole? Yeah. All right. So yeah, you guys got it. Restriction, measured airflow, flow rate. So that's our flow rate sensor. Out of here, and then up into here. So the foam, I think, is there just to cushion. I think this is there just for sound mitigation. It's not really doing much. It's going to deteriorate eventually. Back in over to where the pump is actually going to suck it, and then it's going to blow it here, and it's going to come out here. I've looked for these pumps. Yeah, I hope the foam is antimicrobial. I know, it's going to catch so much shit on its way in. I don't know what that's all about. Is it special foam? It doesn't look like special foam. I've looked for pumps like this. And they've been very expensive. So I want to kind of look up the part number of this thing. Because if we can, I mean, I can. This is essentially what we've gone in here to get. This pump. This pump is enough that you could make something to give you positive air in your dust mask, right? Or I've seen these things attached to battery packs for respiratory devices. So like big masks that you wear when you're doing like sandblasting and stuff like that. They sell positive pressure regulators like this. They just put a HEPA filter on the other side, and they put a bunch of batteries to control it. So we've got a brass plug in one end, which antimicrobial, et cetera. Brass plug in one end, and then we can see the impeller on this end. Let's see if we can look this thing up and figure out what it is. What are you? It doesn't look like there's a ton of part number stuff on it. That's going to be a Philips internal number. Yeah. Hey, look, technically, you could stick this into a small, maybe 2-stroke motor, and it would technically do some work. You'd have to make sure that this airflow can overcome what the engine likes. I don't know, technically it could work. I want to get this thing pumping air, though. Yeah, that's going to be an internal Philips number. There are no other markings on this thing. Lame. Super lame. Lame. That might actually seal. All right. Yeah, no part numbers on this thing. I've been looking for a pump like this, and I was hoping I could get data on it. You would think they would at least give you a part number. There's a number 1 on it. I can look up the QR coded thing, 262171A. Yeah, we're not really going to find anything. I'm finding stuff from the Walmart Superstore. Not as easy as electronic components, huh? So here's the deal. Chat is dumb. They're very dumb. Chat is very, very dumb. It hurts sometimes, but I get to deal with you guys. I don't think this is just a 12-volt pump. I could be wrong about this, but chat is very dumb. This is not a computer fan. This is a fan in a constant pressure autopulmonary machine for a human being to rely on for medical purposes. I am supposing, and I don't know if this is true, and we'll find out, that this might be a three-phase motor. This might be a three-phase motor. Because they just love having that level of control. Now, if this were 5 pins, I would say it is definitely a three-phase motor with, actually, yeah, 5 pins, and then you have 2 position sensors on it in order to figure out where the phases are. You know, like in a hard drive motor, we've got 4 pins here, which means it's some kind of a high-speed stepper motor. I don't think I would relegate this task to a DC motor. Now I could be wrong. I'm gonna sow the seeds of discontent here and say that, you know, I'm not necessarily always right about these things. Their wire coloring is blue, red, and aqua, which, you know, not very traditionally. 3 wires and no ground. Yes, it's called a delta configuration. This could be a delta motor. Let's take a look at the circuitry before we do anything brash, like giving this thing voltage. Other things that we could do in order to test the motor would be to put a multimeter on it and test the leads and stuff like that. But before we just start throwing power around like chat wanted me to do, we need to investigate a little bit. Because it could be perfectly viable for them to have a quiet 3-phase motor in this thing. Having a 3-phase motor gives you a much better granularity of control over the speed of the motor, unless it's a DC with a PWM pin going into it. And so we need to figure out whether or not that's the case. It's going to be kind of difficult to do. So, yeah, this is like Philips, like, went to a motor company and said, can you make us 100 billion of this series of motor, would make this little tweak for us? And they're like, yeah, sure. And it's all internal. So we don't necessarily have an external data sheet for this, nor do we have any manufacturing markings besides what plastic they used. We could separate the shells. That would give us a little bit more information, maybe. We wouldn't be able to get the impeller off, though. So anyway, I have not been able to find a motor like this. I've been looking for one for Burn the Subs. We actually have a Dyson vacuum unit. And the Dyson fan that I used to have, I've got up in my bedroom right now. It's starting to make some squeaking noises that are not conducive to sleeping. And so I might be looking to swap out that Dyson fan, in which case we have, because Dyson makes one motor, they make it really well, and they put it into all their products. So this fan has the one Dyson motor with a slightly different external configuration on it and speed control. That's important because then we can actually go into it and check it out and see how they're doing the speed control. I might still be able to use the Dyson vacuum motor to do smoke sucking. Alternatively, this motor right here might be really good at sucking, so we might use this. So we might actually use this with all the CPAP hoses and stuff and use this as the control. Man, how much does this machine potentially cost to a healthcare provider? And we're just getting the motor out of it? Okay. All the software that this thing had on it, all that user interface that we looked at. Yikes. All right, let's take a look at the circuit board a little bit. I guess we're pretty interested in the motor right now, so we should probably take a look at where the motor comes in. That's this right here. Here we go. There's our motor. Well, what information do we get around here? Oh, that's the big diodes on that one. What information do we get around here? We've got some repeating structures here for 1, 2, and 3 going into a Texas Instrument part. I don't know if those are associated with a motor or not. Man, this design is a trip. 3 phases going into 3 ferrite beads controlled by 3 transistors. This is a Dreamstation. Yeah, do you have one? Going into 3 capacitors going into the Texas Instruments part. This is a 3-phase motor, ladies and gentlemen. There's a 3-phase motor. Actually, were we under here? I think we were under here. You have another brand? Yeah. What does the Dreamstation cost? Do I want to know? I probably don't want to know. There's like a 500% markup on medical devices. I'm gonna write this down. Well, in Google, 69 giggity C. 80. That was an X. C84 KT. Texas Instruments. Or DRV 8301. I'm starting to think it's DRV 8301. DRV 8301. 65 volt max 3-phase gate driver with buck regulator, current shunt, and amplifier SPI enabled. There we go, folks. It's a 3-phase motor. First generation Dreamstations are recalled, or at least the US are working on a recall from what I understand from my provider. Dreamstation recall. Hey, look at this. I should look up the serial number. Manufacturer Philips voluntarily recalled millions of popular Dreamstation CPAP machines because of possible health effects. Sound dampening foam used in... What did we say earlier? What did I say offhand? What did I mention casually? You guys heard me talk about it. I didn't point it out as a design flaw because I figured Philips was smarter than that. We called it. Chat, we called it. We called exactly what the recall was. We're fucking smart. We are smart, chat. You and me, we're smart. You know, we've got foam in the air path, right? And one of the things that like we're constantly familiar with around here is we're looking at old electronics, right? The wonderful thing about old electronics is they used to put it on foam. They used to put old electronics on this shitty conductive foam, and what happens to it after a little while is it starts to just degrade. It becomes powder. That's what this stuff is. It's becoming powder. I can just roll it in my fingers and it's no longer foam. It's more of a solid than anything else. This stuff is shit. This is not what they're using. This is conductive foam is a little bit more gross. But regular old foam does suffer from that. If you've ever been in an old car, a classic car, and even some modern cars, Prius, that foam deteriorates. And this foam is positioned in such a way as to get down into here, where it'll get its ass fucking blown into a water reservoir. And in, no, I can't, okay, the tubes are, and then into your face. Got cases on ships that are 30-plus-year-old with that foam in it. Ew. Ew. I got an ear full of foam for old headphones. Yeah, one thing to look for if you guys are buying headphones, I don't want to call myself like an audiophile, but I know headphones, and I know audio, and I know audio equipment. You guys should know, because the stream has, you know, tuned audio from me. That's why my voice doesn't sound like shit. The thing about headphones, one thing that you should really look for if you're looking to buy a nice set of over-the-ear headphones, look for replaceable ear cushions, because the foam in the ear cushions deteriorates, and that's what usually takes out headphones. If you're taking care of your headphones, and you know, like once a year, maybe every other year, if you really want to be a disgusting person, you should replace that foam, because it'll immediately refresh your headphones. A lot of people, like a lot of audio crazy people, talk a lot about a break-in period on headphones, and I can tell you, as an electrical engineer, as an enthusiast, as a fan of mechanical engineering, that is complete bullshit. The springing material that's moving whatever cone it is back and forth, unless you have some crazy different technology on your headphones, which you probably don't, whatever's moving that stuff back and forth, it's going to get less springy and it's going to get less good at its job, but very infinitesimally. The main thing that people notice in the break-in period of their headphones is going to be the foam fitment on the sides of your head. Believe it or not. It's not going to be, you may think the audio quality improves, and that might be because it's making a better seal, depending on whether or not, I mean, open air is better, but whatever. That's a big thing. And I have friends who will swear by doing a break-in period and hitting their headphones with white noise and stuff like that. It's a difference of opinion, and it's hard to really bring down to science, but I'm on the side of headphones don't need a break-in period. You just need to replace the foam every now and then, so that you'll get that new headphone feel back, and then a couple weeks later, when it's really settled in, you'll have those beautiful new headphones working just as they were in the past. But the difference is going to be so subtle, you're not really going to notice it. I switched to speakers because something would always go wrong with headphones. So I got Sennheisers, can replace basically every part of them. Yeah, smart. That's, yep. All right. Wow, that's interesting. That's really funny. So we pretty much called it in terms of what, I mean, we didn't put our finger on the button. We didn't know precisely, but I was like, that foam's going to degrade. So it turns out there's a recall because of the sound damping foam. Cool. Yeah, see, they used very soft plastic. They tried to have every piece of this thing that was getting positive pressure air replaceable and cleanable. I mean, there's even some of the smaller like pieces that like redirect air to the reservoir. You can pull out and you can actually clean. They tried anything that was touching or adjacent to moist air, but then they put this god-awful foam in the air chamber. Maybe you can send this one back for the recall. I'm good. Just send it without a motor. Like, hold on a second, what the hell? So this is a 3-phase motor. That's going to make it a bit more difficult for us to fire this thing up. I'll have to figure out what the properties of this thing are. Send it in bits without the motor. Yeah. I'll have to size up a 3-phase motor driver for this thing. I don't want to invent the wheel again. I mean, I've got plenty of motor stuff sitting around. Just put a piece of metal in there. They'll probably just toss it and send a new one. I think they probably go through and refurbish. I'll bet you there's a Dreamstation version that has a different this piece, or they change the foam up. That's funny though. And this is just like epoxied together. It looks like they used caulk on it. Ow, folded my thumbnail. Son of a bitch. Yeah, this is just 2 halves are caulked together to make the shell. 3-phase motor driver. I think I'll have to go through like a hobby shop in order to find them. No, it's not sonically welded. It's caulk. There's definitely glue. Glue and snaps? Nope, just glue. It looks like they put it in a jig and glued it. Yeah. Yeah, because there's a significantly clearer, softer. No Sanic. All right. Interesting. Yeah, so I called it. 3-phase motor driver. Chat's dumb. I'm smart. Get used to it. 600 euros for a brand new one. That's not that. Yeah, I expected at least 1,000. I was thinking like 5, but that's really cheap, to be honest. I mean, the amount of electronics in here probably bring it to like 200 euro, 300 euro, and they're selling it for 6. Probably, if they're selling it for 6, it's probably like 150 euros worth of parts. Yeah, in the US, they're going to cost $1,500 easily. So stupid. All right, so anyway, that is a 3-phase motor driver. I called it. I'm smart. Chat dumb. Spelled with a capital But yeah, what tipped me off? Well, we're a little close to the circuit board. I wish I could show it to you guys a little further away, but up here is where the connector for the motor comes in, and we've got everything on this that's split out into basically the same thing repeated 3 times. So you've got some kind of a some kind of a no-lead package here with big traces running into it, and you have 3 of those. So it seems like you're controlling each branch of this equally. Thank you for the follow. That is indicative of a 3-phase motor design. If this were 12 volts with a sense pin, you would have a pin come in, hit a smaller ferrite bead, sneak its way around and go to the controller, while there would be some kind of transistor or power thing going on for the other pins. There's not. These are all treated equally as equal phases that get switched by 1 transistor, which is kind of interesting. I guess it only needs to go in 1 direction, so they're just bop, 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 pulsing the phases. And then you've got the thermal pad for the 3-phase, for the, what is that thing called? What are they calling it? It is a 3-phase gate driver with buck regulator, current shunt amplifier. So it's the transistor doohickey that's moving it. No, we're getting to the circle with the cutout. We'll take a look at that in a minute. Maybe that's for detecting foam in your airway. Foam! Oh, look at all those little guys. So yeah, this thing works on SPI, so there are probably a couple data lines. We could look up on the data sheet where they are, or we could just look for the lines that appear to go somewhere else. But yeah, it's using this coil. It's pumping up the voltage just a little bit in order to fire off the transistors that are under these things. So whoever designed this, apart from the current sense resistor that it uses, so it's using that current sense resistor. I don't think it's doing a full BLDC thing, but it does have that current sense on it. I wonder if it's doing more advanced current stuff. Yeah, it's sensing the current in 2 of the phases. The 3rd one can be calculated. But it doesn't have a sensor for where the magnetic fields are. So it's not that advanced. I thought it would be more advanced, because you can get, if you know where the magnetic poles are floating around in this motor, and you've got current sensing on the different phases, that's what that very low value resistor would be doing, then you can have very advanced control of this motor, because you know where the rotor is. And so when you have very advanced control of the rotor, you can pull back the speed, keep the efficiency super high, and have really good granular control of your motor. You can make it run at very low speeds if you need to, which is, as a medical device, is probably a neat thing to have. I think you can get away with the current sense and getting slightly more advanced control. But yeah, they're not sensing where the magnetic field is. I guess they don't really need to. You don't need it to... It doesn't need to be a servo. Yeah, because when it's for... I don't know. Can you sense the... I guess you could do that without... So... BLDC without magnet sensor. Hybrid brushless DC motor generator without a permanent magnet. It's a paper. Bop, bop, bop. Bop, bop, bop. New configuration for BLDC motor generator, which does not use a permanent magnet in the rotor. Oh, no, that's different. I'd have to do a little homework in order to take a look at it. Yeah, back EMF. Sensorless. Yeah, so I guess they're doing... They might be doing back EMF sensing. Triple travel! Keep the follow. Who else was that followed earlier? MS Sunshine. And Jedi Nightmare. Ooh, that is a... Ooh, all those edges on that name. Herr Vizsla as well. Thank you guys for the follows. Yeah, sensorless or sensor mode, and they're looking at back EMF from the coils. The non-powered ground pin would detect feedback. I think so. I'd have to read up on it. It's been a while, man. Motors were my major in college, but it's been a little while, and it's sort of disingenuous for me to try to explain to you guys how these motors work when I haven't really brushed up on my knowledge of that whole thing. I'm not a great student, if you guys didn't notice. I put too many points into charisma. Everybody calls me smart, but if you get me in a room full of academics, I will be the dumbest person there. Which is good, because I can help relate all these complicated engineering things to you guys sometimes. Why are there so many goddamn wires coming off of the power supply too? What is that all about? I got 2 power, 2 ground. Okay, so they're just doubling it up. And then there's the switch sense for when you've plugged it in or not. I don't know why that exists. There's no battery on this device. Okay, so this motor is Bay. This motor is what we are trying to protect at all costs. I can attach this thing to a filter intake here and then have whatever suction coming from that. No, actually, wait. Yeah, we want suction. We want suction. We can have smoke coming in through that, and it can go through a bunch of charcoal and stuff before it hits this motor. But because it's 3-phase, that means I can control the speed. I can keep it quiet. This is what we were trying to do 3 years ago, 2.6 years ago plus, when I was putting together Burn the Subs 2.5. That's why we're doing the CPAP today. All of these things are little stepping stones on our way. We make big steppy on our way to the new Burn the Subs. This will help. This is more of a Burn the Subs 3.0 device, but yeah. The modem port might have a battery module you could plug in instead. Yeah, it's possible. I wonder what they did. They probably recalled these and replaced the foam and then put them all back out into the field. That's more than likely. I mean, there's some big resistors over there by... Well, that's where the SIM card goes. This is where the modem goes. Will it be challenging to control the 3-phase? No. If I figure out what this is, which, I mean, given the specs on the controller, I will just get a hobby 3-phase controller. And if it takes I2C, I'm in even better shape. I mean, I can just buy something that'll do the job. I doubt you'd be much less smart. I don't know, man. I don't know. But yeah, I think I should be able to pretty easily take control of this motor. I need to figure out what the specs are. So that's something to do in the future. But that'll be our quiet suction motor. I bought a bunch of vacuum motors, and we were playing around with those, and I was trying to make a 3-phase BLDC motor controller. It got out of hand. But we had the people at I forget what the motor controller company is. Who make Rain? I don't know who they are. They sent me a bunch of stuff. They actually sent me like more than $100 worth of their test boards to use. No, it wasn't Pololu. I'm talking about like a chip manufacturing, like 3-phase like motor. They're like a big deal. They sent me a bunch of boards in order to test out some of their stuff, and I never got it working. Their software magically just didn't work with my computer. I don't know what it was. No, it wasn't Granite. Granite Devices, I bought their stuff and it immediately worked, and we were able to play around with those. Granite Devices stuff is really good. I don't think I'm going to use Granite Devices for this, for the fan motor, because I can buy like a $35 motor controller board. But yeah. The person with the damn PhD sent me a picture of the problem on her PC by putting the laptop on a scanner. Oh my God. Oh my God. Well, look, when you have a lot of knowledge in a very specific field, you know, I don't know. I'm not going to make too many excuses, but your sphere of knowledge doesn't include how to send a JPEG. Trinamic. Yeah, there you go. Nobody guessed it, but somebody said the 3D motor controller people. Sorry, the 3D printer motor controller people. Yeah, that was Trinamic. They were really nice. They were nice enough that in the presence of a tweet, and I believe it was Pyro that sent out the tweet, in the presence of a tweet, they got into contact with me through Twitter and actually sent us stuff to control their motors. But it didn't work out. Their software didn't quite work out, and I think we were in well above our heads in terms of the complexity. Is that their programming interface? P1? Is this where they hook it up at the factory in order to determine that the user has inhaled a bunch of foam? Can I get a class action lawsuit for this? I stuff a bunch of foam in my mouth. So here's the pressure sensor for one part of the air reservoir. Which part was that? Can't take a screenshot of the crack in the screen. That's, yeah, it's true. I think there was a meme of that recently where somebody was like, yeah, my screen's cracked. And somebody's like, send a picture, and they just send a screenshot. So this is the output air sensor right here, and it's comparing it to atmosphere. So there's just one rubber fitting on the outside of that goes here. Air coming out of the front of the squirrel cage motor or whatever. That air goes into here. I would love to find where to buy a motor like this. Damn it, I gotta find that. There's no markings on it whatsoever. There's just a Philips internal label on it. So that's the output air. Obviously, this one, the very obvious one, is I guess the air throughput. I don't know. That's going to be a volume measurement. And then we come around the bend towards the input after the filter. And we got this little guy right here. This little guy right here, what is it doing? Well, what we have is a dam. We have an air dam. Pardon my language, chat. But we have just a block that's in the path of the air. On one side? Hold on. Air comes in, air goes out. You can't explain it. What the heck? Okay, what I'm seeing here. Air's coming in. It splits on two paths. Hopefully they've got good software to calculate that stuff. Coming around the bend, and as it comes around the bend before this restriction, it's hitting on one side, it's just hitting an air dam. And that air dam comes all the way up here, and then it whoop-de-whoop goes all the way back down. So you've got a higher pressure and a lower pressure. Hopefully this will all be in the data sheet for the thing that we're about to look up. Lord, forgive me for what I'm about to Google. But anyway, it goes up and then down, and it's got this seal around the entire thing. So air goes up and then around and then down. And so I think that's an alternative flow sensor. Maybe a dust sensor, I'm not sure. Let's take a look at if we can find like a part number on this thing. And hopefully, put the inductor in there. Where's L3? What happened to L3? You promised me that L3 would be here. I don't see L3. Where's L3? I wonder what that's all about. I wonder if there's a little power supply for something that they would like plug in externally. There's like some missing components here. And there always are. Some bean counters. What do you do? Oh, that's Bluetooth. Bluetooth antenna. And there's the FCC ID for the Bluetooth, huh? Okay, back down we go. We're looking at, look at those resistors. Holy shit. We'll come back to those. There it is. MT5 and C122. Never before has there been such a cursed combination of components. My God. And then on the other side, there's just like a pattern. Rumble's finally following. At long last. That's the connection to the screen right there, which is going to go directly. Wow, that's not as direct as I thought it would. Look at this spaghetti. Oh my God. I'm going to guess that a lot of that is to get those pins over to here, because I don't think that's the motor driver. Some kind of a thing to do with the memory card. This is all screen stuff and sensor stuff. This is a mess of a circuit board, man. What does this look like? Does this look like Altium did this? I think Altium is probably responsible for this. What the hell is this? Is that a crystal? Oh no, that's the LED. An LED. That's the LED that's associated with above the button to start it up. Tried looking up the motor. The one with the blue vibration things that you have is, there's the SKU, and you say it's $198. What the fuck? Try the SKU here. Oh, I see. So that's directly for the motor. Yeah, from Sears. I know Sears had CPAP machine parts. That's a little odd. No. Fucking Google. All right. It's all right. She had clothes on. Oh, good. Yeah, here we go. This one's only 75, but it's an AC compressor. That's definitely the link that we clicked on, right? CPAP USA is the site. Okay. Oh yeah, there it is. This one is Sears. All right. Well, anyway, that's the replacement Philips part. It's not necessarily the industrial part that they are reselling. There's not really. I mean, the SKU in this case is going to be an internal Philips part. I want a motor that is similar to that series of blower motors. Then again, I have one now, so maybe I don't. What I'm talking about is this air pump right here. That's enough for a lungful, and it moves a decent volume of air. I should know. I've had to breathe against it 2.5 years ago, several nights for like a couple months, right? I've had to breathe against it, and it moves enough air. With this thing moving enough air, you can also get it from almost new CPCP for $39. Oh, cool. Okay, so there's an like an environment of replacement. Hold on, I'm gonna burp. That was a big burp. So there's, just like with diabetes equipment, there's like a black market of CPAP machine goods, because this stuff does not fucking have to be this expensive. This is the American healthcare system biting us in the fucking ass, and I hate everything about it. So you can go on other websites that have parts for these things and get it much, much cheaper. That's very good to know. I don't want to take medical supplies away from people who want medical supplies. Like, I'm not going to go on a website and buy an insulin pump and take it apart here. People need these things to be affordable, because fuck medical pricing. People who really need CPAPs, like, they do a whole hell of a lot of good. You'll live a lot longer if you need a CPAP and you use it. Believe me, like, your quality of life goes up, your alertness, your awakeness, all that wonderful stuff that you get from sleeping normally. If you are prescribed a CPAP and you can't afford it, it would help to look at those sites, because you really should be using it. At the same time, I feel like they kind of overprescribe these things, but who am I to say? I'm not a doctor. All the not a doctors out there could take a bite of humble pie lately. Anyway, so yeah, the motor chat was able to find $190 here, probably much cheaper on some other websites. So a certain celebrity streamer I know turns his mic up and puts his mouth up to the mic when he burps. Disgusting. There's a certain popular YouTuber streamer that I very much enjoy watching that doesn't quite do that, but it's close enough. Link in Discord. Cool. I'll look at it later. Yeah, it'd be good if I at least have a backup source for these things. Yeah, I'm not talking about that streamer. I'm talking about a different one. A different one that you guys may or may not know. All right, so what we're looking at is we're looking at whatever the hell that damn flow meter is. So let's get real close to the microscope here. I want a part number on this thing. It's not J1. Oh my God. J1 intensifies. All right. Shut. Oh, sorry. SMT. Ah. MT. MT. Huh. SMT 20 D6 dumb. Oh, wait for the shaking. Is that an H or an M? No. All right, calm down. I don't need you guys to retype the part numbers. It's okay. SHT 20 D6 UM8. Sensor. So we didn't need the whole thing. There's even Arduino code for it. Temperature and humidity sensor. Aha! Hey, that doesn't look right. That ain't look right. Shut 20. I2C temperature and humidity sensor. So that makes sense. I'm gonna start carpet banning you people. No, I don't ban people. I don't. Nobody acts a fool enough to get banned around here. You have to be real tone deaf to not read the room around here and get banned. There's ever historically been like 3. Anyway, it's an I2C humidity and temperature sensor. That's good. That makes sense. Classic view? Are they updating? There she is. That's what it looks like. There he is. It's a $10 sensor. Holy fuck. One of these is $10? Unless I'm getting 500, in which case it's $4. Oh my god. How can they... Wow, that is expensive. That is I gotta save this one then. From Sensorion. Hey man, what are we gonna call our sensor company? I don't know. Sensory. Sensation. Sensorion. Oh, there we go. I got it. All right. Anyway, data sheet. Data chart. Sensors are us. Now shorten it a little bit. Centurion. Sensorion. Oh yeah, we got it. They're German. Be nice. No. No. Germans get a pass for all kinds of stuff. I'm not gonna treat them any differently around here. Maybe they named the company first. Sensordyne is what you would get in a 90s and late 80s action movie, sci-fi action movie as your bad guy. Welcome to Sensordyne. No, this is Sensorion. Sensorion, what do you see? My sensors are indicating that there are Romans ahead. All right, so let's see. Fully calibrated. That's good to know. That's what I put on my, that's actually on my my resume. Fully calibrated. Put that on your resume, guys. Fully calibrated. Joke's on you, they're Swiss. You told me the information and then you told me it was wrong. Digital output, I2C interface. I like that because that means I can plug it into an Arduino like a dumb guy and then I can start using it. We might do that. We might desolder this part and put it in to something. We could see if we can take over this thing today. Because I do want to get like the pressure sensors and stuff like that. I would like to get out because those are good parts. Those are good parts. Sorry, I keep whenever I like act at all, I'm like looking over to the side. I don't know if it's totally apparent to you guys, but I'm super vain and I'm looking at myself to see what I look like on camera to see that I get it right, which I probably shouldn't do as much because it makes really awkward visuals. Like I'm looking over at the video monitor screen where I've got me in the corner. That's me in the corner in the spotlight, and then the video window that you guys are seeing is everything else. So, sounds like the plumber is now here. Low power consumption, excellent long-term stability. So that's probably why they chose the part right there, right? That's probably why they chose the part. DFN, dual flat, no lead. That means there's no pins coming out of the sides. I guess everybody got fed up with the 1 or 2 bends that you get in parts when you... All right, censor that one. Sorry, that one was brewing while I was talking. Nobody butts bother in the corner. No, I guess they probably don't. I turned off the fart machine because there's a plumber here and I don't want him to have PTSD. I'm doing that for the plumber. So we have no board and no fart machine. There's literally no interaction between chat and me. I'm building walls between us, chat. I can't stand you anymore. That sentence hurt me. Me too. Streaming, you kind of endure a little bit of psychic damage during. You guys will get the fart machine back, of course, as soon as that guy leaves. So don't worry about it. And why are we here? You can leave. I don't care. I would be doing the same show to 3 viewers, and I have. I'm happy to have you guys here to enjoy this with me because we can make fun of other people. We can get a little Schadenfreude with the mistakes that they've made with this part. Or not. Or not. Whatever works. So the Shut 20 humidity and temperature sensor of Sensirion. Sensirion. Industry standard, form factor, and intelligence. Industry standard intelligence. What does that look like? You're forced to stay. I've locked the door. Embedded in a reflow solderable dual flat no lead package. What I was saying, 3mm by 3mm. What I was saying earlier is that I feel like the whole industry has gotten fed up with pins, which I'm happy for. I am fed up with pins too. We can hand solder a dual flat no lead package. We've got a little tiny bit of the solder pads sticking over the edge here that we can take advantage of. I've been dealing with flat no lead packages since college, which is a million years ago. Let's just say there were more zeros in the date, the year. So way back in the day, you know, this stuff existed, these flat no lead packages, and people were like, how in the world are you going to solder that thing? And it's like, well, you put it down on the pad and you flow over one corner to anchor it, and then you can put a microscopic amount of solder on the other pads, and they'll just solder. And if you're lucky, you have hot air stations, and you can use that. I'm wondering what the hot air station is going to do to this. I don't know if I can use the hot air station to remove it. I'm going to have to. There's no other way. You need a hot air station to work with these things most of the time. You can build stuff up without the hot air station, but you can't rework it. I guess you can if you use chip quick. But yeah, reflow solderable dual flat no lead 3 by 3mm. It provides calibrated linearized sensor signals in digital I2C format. That's pretty cool. Capacitive type humidity sensor, a band gap temperature sensor. Ugh, that's crazy. And a specialized analog and digital integrated circuit. All in a single CMOS sense chip. Yields an unmatched sensor performance. Okay, every sensor is individually calibrated and tested. Set of features, blah, blah, blah. And there's our package. So it does have a big heat sink under it. It's a dry heat, yeah. Yeah, it's double flat. The sensor, yeah, at least the sensor would know that I'm using the hot air station. That's true. How much heat sinking does it really need? What do you need in order to? Okay, what's our voltage here? I mean, this package layout, I'm not sure what I'm going to be able to do with. We only need the 4 pins: serial data, serial clock, VDD, and VSS. Which might mean that I'm able to put it on something big and breadboardable. I don't think I'm gonna have. I'll have to look through stuff to see if I've got anything that'll fit that. This is not a traditional data sheet. I enjoy having all of my mins and maxes in tables immediately under all this, immediately under the initial data. But here we've got like performance data that I'm not interested. Here's the electrical specification. Man, they made this in Microsoft Word. They definitely made this in Microsoft Word. Electrical specifications. Okay, 3.3 volt device. Sleep mode, blah, 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 blah. VDD3. Heater. 2-wire interface, I2C. Okay, cool. So we've got I2C. Here's a bunch of the parameters. PV equals nRT, all that fun stuff. Oh, what? A section for the layout? That should be at the end of the data sheet. Weird. This is a weird data sheet. These guys are weird. So to minimize heat transfer between your device and the sensor, you should have cutouts. It looks like Philips directly followed that. You could solder wires to it instead of right to a board. If I soldered wires to this board, I would be powering up stuff that I don't want to power up. If I transfer it to my own PCB, then I can, plug it in and get some sensor readings off of it for fun. Yeah, it'd be kind of cool. A sensor like this is what, that EKWB makes a TEC cooler, a thermoelectric conductive, those devices that you put a shit ton of current into and it transfers heat from one end to the other. they have something like this in there sensing the relative heat and humidity of the outside world so that it doesn't cause condensation. Condensation can kill, you know, especially on a computer processor, condensation can really ruin your day. So they can cool it right above the point of condensation, depending on the humidity and the temperature in the room. This would be a good sensor for that. Yeah, Peltier or TEC, thermoelectric cooling. It is like an engineering, thermoelectric coolers are like an engineering 101 device. Engineering 101, when you have stars in your eyes and you think the sky's the limit in terms of technology and the capability of what you can do, and you have absolutely no idea all the limitations that you're going to run into. And so you look at something like a thermoelectric cooler and you go, that is an amazing device of mythical properties that nobody's using. Let's build a can cooler. And then you do, and you're like, these things fucking suck. And it's using 1 billion amps of power to do nothing. And that's when you're a little bit more weathered as an engineer afterwards. I used to have a computer that had thermoelectric coolers on the side. It was just some camper van refrigeration unit. I think that mindset in harsh reality applies to most degrees. Yeah, I just know that the TEC cooler is like, that's like the focus for a lot of freshman design projects, or at least it used to be. It was a wonderful like bubble popping moment for everyone else. I had already gone through it by the time I got to college. This is a very simple device. I wonder what kind of commands it's running. That's pretty cool. All right, so let's remember this thing and come back for it. We'll come back for it in a little bit, and we'll get it working on the Arduino. I can probably find code for it very quickly because all the search results had this device as the blah-bitty-blah Arduino. You know, if we were really clever and creative, we could cut out this part of the board, and I could add pins to it. Because, like, we definitely have SDA, SCL, power, and ground running directly out of this board. So I could scrape up the edges and produce... Well, we'll think about doing that. I'll think about doing that, transferring this puck over to something else. They even have a ferrite bead for it. They're treating it like it's a foreign device. Weirdos. I just think it's really cool when we do reverse engineering like this. When we take apart a product that somebody else built, and they built it to their own specifications, and they made it to do the things that they wanted it to do, and we take it and we go, hey, look, that's a cool sensor. And then we take that sensor out and we plug it into an Arduino, and then we start using it for our own nefarious purposes. That's my favorite thing in the world to do. We did that with the Steam controller, and we were able to get XY position data off of their little touch sensors. This is why it knew what date it still was. You little bastard. That thing's been snitching, telling them how long it's been since I used it. Since I used the CPAP. What else do we got? Here's our modem. Big diodes going into the modem. Don't know what that's about. There's probably a lot of power going in there. Modem and or whatever. It's I guess just the expansion slot, right? Is it a double coin? Single coin? It's interesting. You can buy these off of DigiKey. When this battery dies, that's it. It's supposed to be really, really, really sipping from this thing. It's not exactly an LED throwy. Although if you buy these, you can make an LED throwy pretty easily. You can just solder the LED across those leads. But once this thing is dead, you got to do desoldering in order to get rid of it. There's some bastards for putting this device in here. Because when this device, this overall device gets old enough, this thing is dead. It'll no longer save your settings. The only way to get it to do that is to fully desolder this and solder a new one in. That's evil. I don't like that at all. I guess Nintendo did that too with their data storage, and it's only recently, well, only recently, or has it been a while since all those batteries have died? Everybody's copy of Pokemon from the 90s is liable to lose their save data. Although the copies of Pokemon that I had were working pretty well. We fixed up the GBA. Yeah, there's your modem. There's your modem plugging in. I don't think it's reversible, but... And I don't know what else you would expand this with. It's got 4 data lines, so probably pretty fast data transfer going between these things. Oh, look at that. This is a programming header. Programming or data connection. These are there just as anchors. And then you've got your spring pins that fit onto those. I don't think that saves you a ton of space, but I've always been tempted to try to use one of those. Yeah, I don't... Would it be JTAG? It would just be straight up JTAG. Cosmo Quest, rating with a party of 20. How's everybody doing? The board is full. The Burn the Subs, I don't know if you guys know, Burn the Subs is dead. It's dead. It's full. It's over. I need to buy new wood this weekend. And we're sort of working towards, in some ways, the improvements that I'm going to make to Burn the Subs in order to run a new board. I'm going to try to find a live edge board, staple that up to there, and we got to figure out how we can find the edges of the board and like mask it so that, you know, all those names can still go up on the board. The new board is going to have one size for names, one size for gifted subs, and then all of the people who have subbed to the stream in between boards are going to be thrown into a pool of names that will have a random selection order. So the first name up on the board is not going to be the first person to sub. There's been, I got an itch beyond my glasses here, hold on. There's been a lot of debate about, like, a lot of discussion with people saying, you know, like, it's not fair. Like, I don't, you know, my sub is up at a certain time, and I don't know if I can wait on it long enough to get into the board first, or, you know, my sub is up too close to the board being active again, so I won't be able to get there first, blah, blah, blah. I want my name to be in a big size, etc. Because before, when we had the board running, the size of the font went down incredibly fast. It was exponential, in fact, and then it asymptotically approached the smallest size. So instead, what I'm going to do is one size for subs, one size for gifts. The gifts will be the single line font, subs will be the double line font. Everybody goes up. The initial names are in a random order. So we're just sweeping through all of those concerns, right? So were you able to find a live edge board? I didn't go out. I didn't feel like going out. You ever have one of those days? I have those days a lot where I just don't feel like going out there into the burning wilderness of Delta variant, where, like, I got a hoagie today because I did feel like going out. I didn't have a lot of time, but I still went out, and I was getting like looks for wearing a mask. And I'm not in like rural Pennsylvania, you know, we're pretty civilized here, but it still seems to be about 50% mask. And I'm, what am I, 4 months out from the second vaccine shot, and I'm a type 1 diabetic, and I'm fat as shit. So I'm not taking any risks. I just didn't feel like going to Home Depot. I will do that maybe on Saturday. We'll see. We'll see where things get to. But yeah, I gotta get measuring tape and go to Home Depot, and it's a whole thing. So I was just like, you know what? I'm gonna stay indoors today. Anyway, we got a CPAP machine. Speaking of being fat as fuck, I have a CPAP machine that never really worked out for me. And it was actually recalled. So we've been looking at the internals of this thing. The motor in it is a very nice blower motor, and this would be very nice to put as a vacuum motor for Burn the Subs, so we can have smoke extraction through charcoal filtration. We prefer you alive. I'm not sure based on some of the comments that I get. But yeah, so this is a really nice 3-phase blower motor. If I was looking to do some cosplays, I could use this as a breather motor. Or if I was looking to make, which I had in the past, I was actually looking to make a positive pressure breathing system for, like, you know, dusty environments, right? I wanted to do that. I wanted to make one of those for fun. Couldn't find a motor to do it. This would be a really good motor to do it. Found this in the center of the CPAP machine. Pretty pristine condition. It's 3-phase. We found out by looking at the circuit board that this is a 3-phase motor. So I will need to size probably a mid-sized 3-phase motor controller for this thing that hopefully speaks I2C, so I can control it with the rest of what do you call it? The control system for Burn the Subs. Now, as we were looking at the air path in this thing, there's a lot of sensors on this doing metering the amount of air going through, checking to see what pressure the output is versus atmospheric pressure. We just looked at a sensor that did temperature and humidity of the air coming in from the outside world. So we were looking at this thing, and we were looking at the air path to figure out where these sensors were and what they did. And it turns out an off-the-cuff comment that I made. I said, you know, they're putting foam in here probably for deadening sound, but this foam is going to disintegrate eventually. That's weird that they would put foam in there like that. I guess it's just a dead sound. And then somebody in chat, and I forget who, I'm sorry, a chat member informed us that, in fact, the Philips unit was recalled. I'm like, oh, I wonder why this Philips Dreamstation was recalled. We looked up the reason for the recall. They said the foam used for sound deadening can deteriorate and get into the air path. There's not a whole hell of a lot of filtration at this point. This foam is post-filter, and if anybody's worked with like an old car or any old stuff, an old stereo, an old speaker is going to have foam in it that's turning into dust. Dumb, Philips, dumb. Dumb, Philips, dumb. Dumb, 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 dumb. Why did you do this? This foam will disintegrate, and there's not a whole lot of filtration stuff post the foam. I mean, basically what you're doing is it's going to go into this tube here. It's going to be rerouted slightly by this tube, which is, this is just a flat tube. It's going to go into this reservoir with a heated bath of water. Hopefully there's enough water in there. These are, by the way, these should have been cleaned in a dishwasher. I didn't do that. But that air is going to come in here, and if the particles are small enough and it's airborne, then it is open season for this stuff to flow out of the reservoir and all the way into your freaking lungs. I wonder if I could reuse any of these parts for burn the subs. I don't know if I can. That'd be kind of cool if I could. Yeah, anyway. I don't need moistened air. We need suction. We don't need blowers. But anyway, yeah, that's apparently a recall that they had. I find that kind of interesting. Never heard of it because I stopped using the unit like probably a year before the recall. All right, so we don't need all of these views. We could just look at the thing. Sapporo Jones, thank you for following. According to the recall notice, some of their full-on ventilators had the same problem with foam. Yeah, somebody is probably under the gun about their wonderful decision to use foam inside of their air reservoirs to quiet things down. I wonder if that's down to somebody who made a decision like, you know, like, well, it calls for this foam, but if we use this foam, we can save money. You wonder if something like that happened behind the scenes. What are these giant resistors doing? That's my other question. We got two absolutely enormous. The engineer gets thrown under the bus. Turvey, I challenge you to say stuff that's positive every now and then. God. Fine. I don't think the engineer would be thrown under the bus. Power, yeah, we got big power resistors. What are they doing? Why do we have giant resistors over here? Well, we've got a sell. What? 7805? Are you really that hard pressed to create 5 volts? It's a sleeping foam party. Yeah, there you go. Why do we have a 7805? What's going on? It's a 78M05, which is just a 7805 is a linear regulator, right? So, I mean, the 6 amps of 12 volts that's being thrown at this thing is being tossed at the simplest of power devices. These things I think the 7805 existed before electronics, and it will exist after electronics too. They have been, and they will always be. Oh, 78M09? Yeah, maybe it's the 9-volt version of the 7805. It's still like really, this is like putting a rock in your fighter jet. Like, why is this here? This is ancient technology. This should not be here. We do have 2 big power resistors, so maybe this is heater control. Where's the, yeah, there's the, so here's the heater. Big caps, big resistors, 7805 or 9. So if you're the engineer and you see something that might cause an issue down the line, yeah, write an email to your supervisor and keep the email. Yeah, exactly. Exactly. Watch out for number 1. but you make sure to have a paper trail on stuff like that. Who the hell knows? Who the hell made that decision, though, to use shitty foam? That's crazy. I would assume that one of these lines is going to be from the sensor, because isn't it? Okay, so at the end of this thing, I have to get out the manky hose and all the disgusting attachments. But you can see there's that little shark vein right there. And I thought that little shark vein was a sensor of some type that the CPAP machine was using. 78 series is far from efficient. They're reliable and probably be available forever. Well, yeah, but if you're making a medical device, I would think you'd spend an afternoon specking out, you know, a better voltage regulator. Oh, God, this old silicon is disgusting. It's absolutely vile. Ugh. Ugh. That's getting thrown away. That's getting thrown away. I would have liked to show you guys the infinite whistling, but it's too disgusting. I'm not putting that on my face. It's just been sitting in dust for way too long, yeah. So yeah, anyway, the attachment over here at the end of the hose, there is what looks like a sensor. It's just a little shark vein, a shark fin at the end. And then over here, we've got 3 of the 6 pins go into this. I would assume maybe the other 3 go to this heater right here. I got basically this unit clips onto the end of the on the end of the CPAP machine. It's got 6 connections. I wonder if they have different sized ones. Can I get an extra large? But yeah, that interfaces with this. So we've got 6 connections to the tube that's carrying air that heats it up. That's what the twisty bit is, a heater. And then a heat pad on the bottom of this, which I assume if we remove these connections, we could see more about the coffee warming pad. Might as well grab that right now, because I want to get the identifiable information out of here. All right, I hope by means of recap, you guys are caught up. We're not doing anything too complicated today. We're just taking apart a machine and figuring out how it works. Yeah, flow sensor. That's what I'm thinking. Because, yeah, okay, so the pressure, the intake air volume will be indicative of a crimped hose. But that sensor at the end will give you a sense of a pride and accomplishment. It'll give you a sense of what the output air temperature is. So you've got intake air humidity, intake air temperature. You've got a metered sensor for volume. You have output air temperature, I guess. And then you have a heater over a reservoir in order to... Oh, yeah, and then you have output air pressure and atmospheric pressure. All that data can be put into this thing, and it can figure out exactly how much humidity it needs to add to the air, I guess. Yeah, this is just a sealed heater. That's neat. So it's got 3 pins coming out of it, and then 3 more go up to the next step. So here's a coffee warmer. Yeah, that's all in harnesses. Interesting. 3/22, 2017. Yeah, there we go. 4 years ago. Depending on how long this thing sat on a shelf. But yeah, it's a potted heater. I don't know what I could do with this. I could heat up my coffee. So, and then the other 3 here go up to the hose. So is the hose just a DC heater? It's got three pins. Maybe the brown wire is a sense pin? Bad year. Fully calibrated. That's right. I am. So yeah, okay, which ones are which? We can figure it out. 6 pins, 3 of them come down here. They go to that big bridge. We've got a big transistor on one of them. That's for the 3-phase motor. That's a different set. So it seems like the front pins might go to the coffee heater. Kind of looks like they do. Well, one of them's pulling from there. And those 2 go up. Okay, so those 2 go to separate diodes. None of them have like thin traces on them, do they? Although coming on the other side of the diode. Maybe the diode's there just in case. Because, yeah, we got two things there with ferrite beads on them. What is that unholy trace right there? Ugh. Okay, that one's going down and around. Yeah, and it goes to two separate lines over here. God knows where they go from there, because this is a 4-layer PCB. We're not going to be able to completely trace out where everything goes, unless they go to these grounds over here. But I think they're in this cluster. Who knows? Maybe those are the two temperature sensor pins. All right, so I have absolutely no idea where they're headed. I don't know. That's probably going to be where the main chip. Nope. This is a hellacious circuit board in terms of the trace layout. And man, I would feel pretty accomplished to have designed this circuit board, because there's a lot of stuff here that they managed to get connected. It's hell for us though, because there's so much. That's our flow and humidity sensor, by the way. Power stuff, big power resistors. I think we've just about exhausted all the stuff that we can look at, huh? We got a giant ST microelectronics chip, giant ARM processor. Can you believe it? Well, okay, so next step. Does that have any pin? Okay, it's got 4 pins for the sensor. I want to get some of these sensors out of here. Add them to my own collection, huh? If that's all I can get off of this board, then so be it. Sensors and the humidity and flow, or sorry, the humidity and temperature sensor over here that thing might be kind of cool to play around with. There's a Bluetooth chip up here I'm never going to use because it needs too many peripherals. A surface mount pressure chip, which could find its way into a car if I happen to get another Mega Squirt someday. That's about it. I don't really fathom a lot of the other stuff in here is going to be recoverable or useful for my own purposes. Just the pressure sensors, temperature sensor. That's it. I don't even want the buttons off of this thing. I'll just buy buttons if I need buttons. The knob for the screen might be useful. It is on a little flat cable though, which makes it a lot harder for me to use. I don't mess with connectors like that. Not me anyway. Yeah, that might actually be pretty useful. Ooh, wow. Oh, it's really crunchy. The piezo element? Another phone call. Yeah, I'm sure that's very legitimate. Why is everybody calling me on a Friday? They can leave a message if they need to. I'm really pissed off at all these spam callers lately. Have they like redoubled their efforts? It seems like I'm getting more. What flies real good? What are you talking about? Okay, these are molded into the front plastic, both the screen and the knob. The screen, everybody's like, you could use that screen for blah, blah, blah. No, screens are very difficult to find a use for. Screens are actually very difficult to find a use for because you don't know what the protocols are on these things. I think Ben Eater did a video on reverse engineering a screen. I have absolutely no idea where he got any of his information from because it's absolutely ridiculous. The piezo element. Hell no. I will not ever. I hate buzzers. Actually, I don't know if this thing, I don't think it is piezo. I think that's just a heater. The puck. Man, rest in peace 2017 device. So these are plastic molded in. What they did is they put the PCB down and then they had just like a hot thing come down and press that so it works like a rivet. So the best thing to do for these is just to get a pair of flush cutters and destroy them. If you have to repair something that uses these plastic rivets, the only thing that I can recommend is that you come in with a soldering iron and just poke them carefully and it'll recreate the rivet. This is a CPAP machine from 2017 that's actually been recalled because of the foam they used. We discovered that midway through. I mean, I was already committed to destroying this thing. But apparently, Philips put foam into the air path and the foam deteriorated over time, and it caused issues. Too bad. If I was still using this thing, I could get a class action lawsuit out of it, huh? Just inhale a little bit of foam. What's a pair of lungs these days? Actually, that's a pretty dire cost these days, let's be honest. There you go. I distorted them a little bit when I did this. I shouldn't have. Should have been a little bit more careful. That's all right, though. What the hell? What the holy hell is this thing? Man, this is like a minimal encoder. I might take this apart just because it'll be funny. Look at this thing. That's a weird goddamn encoder. What are you people doing? What is this? Some kind of joke? Some kind of joke to you, this encoder. What is it? Oh, it really clicks over very, very harshly. And it does have a button action on it. But we can take a look at this is just the product. This is just the whole thing. It is just an encoder that exists. What a complicated thing, huh? Well, very clear how we're going to get into this thing. We're just going to bend those tabs and then the whole thing will come apart. Looks pretty cheap. It's probably because it is. Let us release the knob. Okay. Yep, easy does it. Very simple. So, it's just scraping traces. We're just scraping here. Bop. Bop, bop, bop. All we do is just scrape traces in a particular order, and as we tap over from thing to thing, the wipers are going to do their job and connect piece of circuit board to piece of circuit board and produce a pattern, an A-B pattern that is going to pop off in a certain direction depending on how you're spinning it. And for most devices, that's all the data that you need. It's all perfectly fine. And then, of course, in the middle, when you press down on the knob, it's going to press down on this little metal dome. And that metal dome is just going to click over, and it will produce a button contact for you. I can't really show these because they've done the same thing with the plastic riveting in order to attach this plastic shroud around their little metal dome. Let's just go in here destructively because I'm not going to use this for anything. Maybe the knob will fit on my 3D printer. I think it will. It's not quite the metal knob though. I like that metal knob, but the metal knob doesn't quite fit. Whereas the plastic knob is made for, I think, the exact same size rotary thing. So I might be able to just put that in. The 3D printer has a 3D printed knob, and it's not that good. So yeah, all it is, and this one they didn't use any special, patterns for. It's literally just a disc that pops over. Sometimes there's like a structure in the middle that's printed into the disc. Sometimes they'll use like cross-hatching kind of patterns on this. In this case, it's just one contact around the periphery that this is in contact with, and then when the button snaps over, it just connects the center. That's it. Most of the buttons that you have in devices are just a disc of metal. Just a metal disc that goes thud 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 when you push it. And then your encoders are just little hair thin bumpy wipers. Little bumpy diaper wipers that go across a substrate with a pattern on it. You can get more complicated than this thing in order to get encoding in, but this is just a simple A/B encoder. So there's two wires and a common, and that common gets connected to those two wires in such a way so that A starts a square wave first, and then B follows up a square wave later, or if you're going in the other direction, B starts a square wave first, and then A starts an out-of-phase square wave with that. That's it. Would you be interested in building a ham radio? I've always been interested in building one over transistor radio myself. Get around to it eventually. I do want to do stuff with RF, but I don't know if I'll get around to doing a ham radio. I don't have it on my list. Our list of projects is very long. List of projects is very long and extensive, but I do want to get into one day getting into radio stuff would be kind of cool. I don't want to become my old boss from University of Pennsylvania. The man's name was Dr. Britton Chance. Everything optical he's invented. He's a crazy man. He's done a lot of biological optical stuff, but his list of accomplishments is ridiculous. Anyway, had him as a boss, and we went to the Florida Keys to sail with him. He had an entire, basically just like area of the main room of the house that was all ham radio stuff. He's one of those. He's one of those crazy ham radio people. So 4 o'clock in the morning, he would wake up, come downstairs, and because I was a teenager at the time, I'd be sleeping on a couch, before we set off sail. And he would start Morse code communicating with somebody, God knows where 4 a.m. was the morning for them. He had all this equipment and antennae just thrown into the woods around. There weren't woods, it was Florida. But he had antennae thrown into the trees. His boat was a 42-footer, and it was literally just a bathtub filled with electronics. It had like all the fish finders and the like multiple radios and stuff like that. It was nuts. It was European. I don't know. Yeah, I guess it was 8 a.m. for the Europeans, so he was probably communicating with them. Depends on. I don't know if he was doing like bouncing off of the atmosphere or what. I looked at the requirements for like getting a ham license, and I just didn't want to memorize that stuff. All right. So, it might have been a 26-footer. I might be getting my boats mixed up. It might be a 26-footer. I've got 40 something and 26 stuck in my head. I don't recall which. It wasn't a big boat, so I might have quoted the wrong number. Let's get some of this stuff out of here. Let's steal some sensors out of this thing. Too bad we can't steal some of the code out of this thing. I assume the part where it measures, the part where it meters the amount of air running into it, senses the temperature, gets the relative humidity of the atmosphere, the pressure of the atmosphere, the pressure of the output air, the temperature at the end of the hose, all those variables that it gets. I assume there's some really cool stuff going on there in the equations and the calculations that this thing is performing in order to keep air of a particular temperature and humidity running into your lungs. But anyway, we're going to hit it with really hot air, and then all the parts are going to fall off. That's what we're going to do. Let me get some of the plastic garbage out of the way. Can you get the firmware out of it somehow? My only experience with that is getting a hex dump. And I've not done it with the STM32, so I don't know what the STM32 is storing in it. But if you get a hex dump, you would need to get a decompiler, which a friend of mine is an expert on. I am not. He's really good with that kind of stuff. I think basically what happens is the decompiler makes some assumptions about the structures that the IDE has created in the microcontroller code, and then you have to go through and evaluate the loops and stuff and sort of clean it up so it becomes as close to human readable code as possible. But the IDE does a lot of stuff in the background in order to make your code run in machine language. So it's a fairly complicated and difficult process, from what I understand. Now, you never know if somebody whose entire career revolves around this happens to be in chat and will speak up. But I don't see anybody speaking up at the moment, so I think what I've described is moderately accurate. That's all I can rely on these days. All right, let's get the silicon mat up here. I'm going to need that because we're going to work on the table surface. I'm going to use hot air for this because it'll be the most painless extraction for most of these parts. And we've got the main board of the thing sitting right here. We know. Okay. Where do we want to start? I guess with the side that has all the components on it. Peh. Beard hair in my face. Yeah, I think what we'll do is let's get this guy out of here. This would be these pressure sensors come in dual packages because you want to get whatever pressure you're sensing relative to whatever pressure is around the atmosphere. One pressure reading is not enough for you to get a good idea of what you're measuring. So they do two, and then you have like a known pressure and a you know, a sensed pressure. But I think the easiest way for us to get at this thing is just to spam it with hot air on either side until it falls off. Now there are usually, this one doesn't have it. There are usually centering pins underneath these, but I'm just going to add flux to all these pins. This is like an SOT style device, SOD style device. And I just got to watch the amount of heat that I put on this thing because I don't want to boil it. Let's see if we can view it on the microscope. It's probably not going to be all that visible. Oh no, that's actually pretty decent. I'll just keep it at an angle and I'll blast one side and then the other and just try not to overheat that plastic. So turn on the hot air, get the cable out of the way, get you all the way over here, see what we could do. See if we can get it off. There's probably like more than just, yeah, there's probably like complicated firmware that goes into that thing that I bet would be more workable. Now, I don't know if I'm going to melt this. I might. This should be stable for soldering temperature, but I'm hitting it with a whole lot more. I'm already starting to smell plastic. Careful now. I mean, what kind of plastics are they using in these things? Usually they're pretty stable for at least one soldering cycle, right? You should only be worried if you smell burnt toast. It's true. Rabba's stroke. Dear God. You guys need your hands held. Please to be coming off of the board. This is a CPAP machine, and we've got many different sensors on here, yes. Or removing them, because this is a recalled CPAP machine, I can say. I can feel better about stealing these parts, because they've been recalled. I'm hoping I don't melt this fucking thing. It is plastic, after all. I'm not getting the solder is not cooperating. I don't know what's going on here. I put down flux. Probably blew it all out by now. Plastic's gonna melt in like a millisecond more of this heating cycle. I need more flux, probably. Is it glued down? Could that be it? It could very easily be glued. Okay. I suspect glue is at play here, but I'll add more flux just to be nice. I wouldn't put it past them to glue the components down. I mean, we've got an extensive motherboard here with a bunch of different stuff on both sides. The through-hole stuff will probably not be glued, but stuff like this could very easily have just a little bit of glue on it to hold it down during the soldering process. That could very easily be what we're dealing with here. I'm holding it because then it'll slide off. But I think the glue's holding it. That, or I could add solder to it and maybe it'll convince it a little bit more. Yeah, all right, plan B, solder. A smell of a hot air station in the morning. All right, I gotta be careful because this thing is hot as hell. Hot, hot, heat hot. I want to recover this stuff. Oh God, I don't have the right tip on this iron. It's all right, we'll just power through. This would chip quick. This would be a lot easier. All right, give the solder a little bit of refresh from 2017. Is glue a type or form of plastic? I don't know. Guess so. I guess so. So this is 500 degrees C. This is well above soldering temperature. I've added a little bit of solder to this so that when I get this thing to get to melting temp, I'll have a little bit more time to get over to the other side. It's starting to get hot over here because of this. The only other thing that I could think is that there's a little bit of glue, what is designed to hold this thing in place during the soldering process. In which case, I'm not really certain how I should go about this. I mean, I'm lucky enough that it's not melting the plastic material. But if I get at this with like a pin tool... Oops, here, back on camera. There we go. The center of this mat is getting a little too hot. I should probably have the vise under this so I have a little standoff distance. There we go. Yeah, there was I think a little bit of glue. That or it was just sticking from surface tension. Might have been surface tension. Yeah, so these, if I didn't ruin the sensor with all that heat, these are really cool. These are good. Differential pressure sensing units. So you can figure out what the atmospheric pressure is, and then you can figure out what the pressure is inside of the thing that you're measuring. I would assume, using these part numbers down here that we can barely see, we'd be able to figure out what this is and what the relative levels are. I've seen these used in ECU software, devices, in order to do all the air metering and stuff like that. So we could probably find a use for it, maybe. Have some fun with it. Here, I'm gonna put everything else up on. There's like a bubble. The desk mat forms bubbles when it gets too hot, so we gotta move up. We gotta move all the way up here. Can I back out like a lot? No, I won't be able to focus. The optics on this camera aren't quite what they should be. Okay. Next thing. Well, I mean, I would like to get the big guy out. This big one right here. This is another dual pressure sensor. It has a grand total of 4 pins and a lot of plastic around it to hold it in place. If I can get those 4 to desolder at the same time, then I could probably push down on it and it'll fall out. So let's see how I'm going to be able to get the circuit board held so that I'm not holding this thing back. I could clamp the vise onto it. Actually, yeah, I can. All right, cool. I'm going to clamp the vise onto the sensor itself, and then I'll lift the circuit board from it. Solder suckers leave a little bit of surface stuff that kind of like grips the thing, and I'll make it harder to get out. Easiest way to do it is to get all 4 of those pads molten at the same time. Pull the circuit board out. Also, I've got a thermal camera. Of course I'm going to do it this way. I mean, I could do, I could get those switches and stuff too, but they're not totally worth my time, I don't think. Depends on how much of a roll I figure I'm on. Oh, those need flux, actually. A little bit of flux, a little bit of heat. Bring the heat, bring the noise. Look at the heat dissipation of this board, though. The entire board has now taken up all that heat. There's a good ground plane on this. I could probably do this with just a big solder blob. I don't need the hot air. But while I got the hot air out, I might as well use it. Let me add a little bit of a solder to this. Where is it? There it is. Looking for where my soldering iron was. You don't have to refresh the solder, but it does help when you're trying to extract stuff from a board. I'm doing this very daintily, though. I'm doing this very daintily. I'm using hot air so I don't stress out the board. That's not really necessary. I don't care if this thing survives. Yeah, if this is unleaded, then adding my partially leaded solder is helpful. I think most of the air in this room has been through the soldering, the hot air gun, which is not good. I don't know if this is quiet. That doesn't look like molten solder to me. I think that, you know what? I think the big iron tip is going to be the way to go with this. On second thought. God, I'm about to sneeze. Edit the hybrid auto. Well, that's a hell of a thing. I saw a good project where it was a Porsche 944 that had an electric motor in it, and so we had all the motor control-y stuff going into the thing. And the cool part about it was, in order to do long trips, he made a long-haul trailer. The long-haul trailer was just a push trailer. It had a little throttle cable that went back to it. So he was pushing his 944 with a little trailer that was actually shaped with a 944. He used 944 body parts in it. So if you guys are noticing, what I'm doing here is completely cursed. I'm trying to get at these little clips while prying up on the circuit board to try to remove one thing from the other. I don't know if I'm able to do it. Most of the board is pretty warm at this point, and I've got the vise is holding, there we go. The vise is holding on to the sensor itself, so I've got that stable connection. That moved a little much. I might have damaged the contacts, but if I carefully walk it out from here, I should be okay. Now walk it out. There we go. Look at you. CMOS Sense. These sensor companies cannot name themselves. They're so bad at it. What do we call our CMOS sensor company? I don't know. Samosens. Let's put technology in there too. Let's also call it technology. That way people will know that we have technology in the name of our company. Samosens. I don't want samosas. All right, remove the solder for whoever gets to use this thing. Yeah, mimosans. Or Samoas, the Girl Scout cookie, right? Is that what they're called? Forget. I forget. Although I could eat an entire package of those. CMOSense 1214812. What the hell was it? I forget the numbers. I forgot the numbers already. What were the numbers? 1214812. Why is my glucometer? My glucometer's like angry beeping at me lately. It really just does not like me. Oh, because my glucose level's going down because I gave enough insulin for once. Yeah, CMOSense. There's no two S's because that would be awkward. And CMOSense is so much less awkward. Oh, is it no E? CMOSense? Oh, Jesus Christ. Gas flow and differential pressure. Well, there we go. That's exactly what this thing is doing. CMOSense. Oh, that went away. Multi-pixel. God, what is this website? Stop it. This website is attacking me. You guys saw it. It came right at me. Oh, is it the same company as the other sensor? That would make sense. I mean, you know, that would sensor, sensing, semescence, semsense. This is basically how they come up with the names for all the different companies, right? All right, later, guys. Sensirion and Semos. Oh, yeah, there they are in the corner. Right there. Sensirion and Semosens. Semi-sense. And Sensorion. Sensi. God damn. So, yeah, it would make sense that they went to the same company for all the different sensors in here. But, yeah, this is a differential pressure sensor. Easy peasy lemon squeezy. Gas boilers. Pellet stoves. We should build all of those. Let's make a pellet stove. Excellent repeatability. Digital differential pressure sensors for high volume applications. Figure range 500 kPa, bottom end, blah, 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 blah. 2-wire I2C interface. Damn it. These are all I2C. Let's make an iron lung. There we go. Is that the new meta on Twitch? That's what it is. The new meta on Twitch is iron lungs. I can wear a bathing suit and Twitch can't say anything about it. That's where we're headed, chat. That's where we're headed. We're going to do an iron lungs stream. Actually, there was a guy for Penn and Teller's sketch that went around in an iron lung. It was the episode on vaccines that I think everybody should see. Because we got a lot of dumb people. Got a lot of dumb people. Did I drink both Dr. Pepper? Damn it. Drank both of my Diet Dr. Peppers. I'm going to switch to Pepsi. I'm going to switch to Pepsi, which a certain streamer went on a rant about, that if somebody has Pepsi in their household, you should be worried about that person. I like Pepsi. I'm stuck to diet soda, and Diet Coke is a little bit like chemicals, even though I don't mind it. Diet Pepsi tastes a little bit sweeter. In the grand scheme of random-ass diet sodas. I was thinking about you when he went on that rant. I was biting my fucking tongue. I'm trying not to be like a pest. I don't want to be a pest in these streams and like say all these different things, you know, because I got that badge, and that badge takes in with it a little bit of responsibility. I don't want to be just some random asshole, which I probably am. Given the way that VoiceBox was like, oh, you're that tech streamer, I'm like, they're definitely talking about me behind closed doors. So, you try Coke or Pepsi first. What do you fucking think? I've had diabetes since I was 9 years old. I'm sipping on a Diet Pepsi right now. Yeah, and according to some people, that means that we should be suspicious of you. You're some kind of psycho. Oh yeah, I can disable the badge, but fuck you. It took me 3 years to earn it. I'm gonna keep that badge on. I don't give a shit. But it does, you know, there's a certain weight to it. You know, diet is not diet, right? What the fuck are you talking about? What kind of dumbass bullshit did you just type into my chat? That's the dumbest thing that I've ever read on Twitch, and there's severe competition for that. Yeah, diet. I like my Diet Pepsis. I think they're better than Diet Coke, but I'm type 1 diabetic, so I'm stuck drinking this shit. I'm stuck drinking this stuff. So, all right, what kind of pressures do we have here? Oh, we have different I2C addresses. Wait a minute. Oh boy, this is weird because you look at I2C devices. I2C is integrated circuit communication. IIC, right? I2C. Let's talk about that for a second. What is I2C? All the devices that we've been pulling off of this board, this CPAP board, have been I2C devices. I really like I2C, and this is a nice modern, we're going to call it 2017 because of one of the dates that we saw on the thing. Do we have any other date markings on this? Can I pin it to a year? Well, 2017 was a marking on one of the other parts. So I'm going to call this a device that was built in 2017. So 2017, we're talking modern, you know, not this decade anymore, but modern technology, right? The cool thing about I2C is it's integrated circuit communication. There are different protocols for communicating from chip to chip to chip to chip, because chips do different jobs. And you can have a big controller chip that does a lot of different jobs, but it doesn't have any of the structure to do something like sense the humidity and temperature of air. I'm gonna burp. Okay, I burped. So you then need to go and buy another device that is then going to sense. I'm gonna sneeze. There's a tickle like deep in my fucking nose right now, and I can't get rid of it. This is a problem with being on webcams all the time. Is I have to treat it like I'm on a stage, and I can't do weird shit like pick my nose. Anyway, so you have a bunch of different chips. The structure of the silicon on one chip can't do the job of what another chip does. This one over here is specifically designed to control a 3-phase motor. You can maybe get a big controller chip that does that, but so you need some way to talk between your chips. You can have what's called a serial peripheral interface, SPI. It's mega fast because there's a lot of parallel lines on it. Or if you don't need to communicate with something all that often, if you have a sensor that you're going to pull not that often. When I say not that often, you think like, yeah, every minute. No. I mean like 6 times a minute is not that often. 6 times a minute is an eternity. 6 times a second even. I2C can get very fast, but it's not parallel. It is a serial interface that has 2 lines. One of them's a clock, the other one's data. When you speak in I2C, you speak to every chip at once, and the chip that has the address that you're addressing will respond. That's a gross simplification of what I2C is. One-wire protocol does something similar, only you don't have a clock line, so you need to synchronize your clock with everybody on the external peripherals, and you go, tick-tock, here's my timing, here's my message with an address, and then everybody replies who has that address. It's a way to communicate from chip to chip without having 50,000 wires going between your chips. I like I2C. It's a very simple protocol. It's like a fundamental feature in a lot of Arduinos. So if we find a sensor that's I2C, we can literally go on the internet, beep, boop, beep, bop, bop, and we can Google it, and we can find somebody who's figured out how to communicate with that chip. And they'll often have a library that you can download, and then it's very simple to just say poll.device and then give the address for it, right? So for no reason in particular, I'm going to go to this camera just briefly and then back to my face. How you doing? I wasn't doing anything off camera. Okay, that didn't get the itch. It still itches like hell. Anyway, so I2C, what I'm looking at with this chip is how they're doing the addresses. And again, I'm going to go to this camera for no reason at all whatsoever. And then I'm going to go back to the view where I'm actually on camera. So anyway, nothing is working. I don't know why. What is in my nose? Help. I need a doctor. Call an ENT. Do they do house visits? What some of these chips do is they'll have multiple extra lines because now they've got all these pins, and they're not using them all. And so they'll have a system of 3 pins where you can connect them to power or ground to do 1s and 0s as the address of the I2C device. Because one of the other cool things about I2C is that every single device on your board is listening to that same I2C line. And so you need to differentiate the addresses of repeated things. If you've got like a port expander that's doing 1s and 0s out of it, which is something that we are probably going to get into soon. If you have a port expander and you're telling it what pins to go high and low, and you have another one because you need more ports, you can double that up. You can do that. That's perfectly fine as long as you give them different addresses on the I2C line. This company has 4 pins coming outside of their device. McFarlane, thank you for following. So if you've got multiple of the same device, the same sensor even, on your I2C line, you need to be able to differentiate between them. This manufacturer, and the reason that I went on this whole tangent, this manufacturer is actually providing different part numbers to give different addresses. And it looks like, yeah, manifold mount, manifold mount. The only difference between those top 2 is the I2C address. That's kind of a weird thing. So maybe you use different products, maybe use different addresses. Another thing you could do is, I guess, have like an I2C line switcher. Those exist, and you can give them an address, and so you'd go over to your line 2, where you'd have more sensors. That's not a great way to do it because you sometimes need to initialize I2C devices. But if you had an I2C bus switcher, you could have multiple of the same address device. But I'm so sorry I'm tiring you out, Nixon Nelson. There's the door. Fuck. All right. So, nose problems aside, yeah, it looks like they're using different part numbers in order to give you different addresses on the device. Let's see. Yeah, you can have up to 255 addresses on it, but the manufacturer usually gives you 3 pins, so you can do, up to 8. So 4812, that's none of these part numbers. 810, 8 blah 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 blah. I guess that's just ordering information, but how do you know what the address is? I guess you can make a program that scans the address and see which one it replies to. But I was hoping we just get like a definitive answer right here. We don't know what the address is. Part name, form factor. It's going to be 25 or 26. I don't know what 500 PA. I don't know what that translates to in PSI. It's like, look, 800, 801, 810, 811, 800, 810. So what is 812? Is it 27? What? That's strange. Oh, well, we don't know. Our part isn't listed in the data sheet. All right, let's get the next one. So the next one is the one that we've already looked up. We already know the information on it. Basically, the pressure sensors are the only thing I really want to grab. That would be the MT5. Oh, my stupid nose. Why is my nose decided to... Hold on. I don't know what's up there, but I'm not getting the endoscope out. I did buy a cheapo endoscope, by the way. If we ever need to look inside of a device and I really want to hook it up. The problem is it only works with my phone. I don't know what Windows drivers I need to run it. So not even a PSI, huh? 0.0725. Oh man, it's unrecoverable. My nose is going to itch for the rest of my life. Whew. So I probably want to stay away from the little window, huh? With the flux. if we ever need to look inside my nose. I used it for my ears just to see. You can only suffer through so many videos of people pulling giant wax plugs out of their ears before you want to check your own. I actually did have a doctor do that to me once, pull a big Shrek-sized plug out of my ear, both ears. That was when I first moved to Virginia, and I sorted out all my general practice stuff. Yeah, it hurt. It actually hurt. And then I was able to hear goddamn everything after that, including teenager alarms. It turns out my shitty ear hygiene, I guess Q-tips push material in and they can cause that to happen. So it formed a de facto earplug that kept me safe during my concert years. I still have a little tinnitus. Actually, you know what? Here's another one, by the way. Here's another one, by the way. It's not tinnitus. It's not an itis. It's not pronounced like that. It's not an itis. An itis is a specific type of thing. Some sensors don't even like solder fumes. I would assume that this would be one of them, but... Bloop. You're mine now! I believe it's tinnitus, but I used to irrigate ears of the Air Force. Once got a pinto bean out of a 40-year-old that had been in there since he was a kid. Oh my God. Holy hell. If I had a prize to give, you would get it. I mean, of all the beans, he had to go to pinto. If you're going to get something stuck in your ear, it should probably be a garbanzo. Good car. Terrible car. That sensor is probably not doing its best, huh? Yeah, it's an itis, not an itis. I don't know. My doctor I know said it was pronounced much differently, tinnitus or something like that. Because it's not an itis. Yeah, it's not. Our itises are viral or something like that. Itis means inflammations. Okay. I was wrong. I ain't no doctor. We already established this. Is there anything else on this board? I don't think there is. This is an interesting application of technology for sure, but there's not a whole lot salvageable on this thing. 78M05. I mean, I'm not going to throw this out. I'm going to put this board. It's going to be in my collection of boards that are in sort of the derelict pile, the soldering practice bin. Yes, indeed, we are stealing components. So if I ever need a specifically this type of button, maybe some of the voltage regulators, if I need a 78M09, battery's going to be too difficult to get out. I don't really care about it. I'll just throw it in the bin with everything else. The battery doesn't present too much of a risk factor, I think. I think this will just go into the bin with everything else. I don't need an SD card reader. I'm not sure. Hell nah with a buzzer. Buzzer, I just need to... What do we do with buzzers around here? You've come to the wrong neighborhood, buzzer. This is what I think of you. Garbage. I don't like buzzers. Yeah, that was a humidity and temperature sensor. I've never seen one before like that. But they're all I2C. So at some point we'll hook that up to an Arduino. It's a little early for me. I don't have a whole hell of a lot else to do with this. This went way more smoothly than I thought it would. I don't have anything to control the motor controller. I need to look up, because this is a 3-phase motor. We know that by the circuit structure that it plugs into, right? Yeah, SHT 20 and 1. How do you know about those? No, not BLDC, 3-phase. Well, brushless DC, yeah, so BLDC, yeah, it is BLDC. Sorry, it's not, what is it called? The super duper control type. It doesn't have sensors, but this is a 3-phase brushless motor. I will just have to find a controller. I'll just have to find a controller, and I can find an RC controller that will do a motor of this size, approximately. I don't think I have any. Do I have any? Had some for the mini drone, but those are in use. Yeah, so I'll have to just find one that'll turn this thing, and I'll measure the phases and stuff like that. I mean, I can get info about the inductors if I measure this thing. But yeah, so I would like to get this thing up and running. It just needs more parts. And then we can figure out from there what I want to do with it. Hopefully I can run it quiet enough that it'll satisfy my needs for a quiet airflow motor for burn the subs. The temperature and pressure sensors are just a bonus. But yeah, we learned a lot today. That was cool, the way this thing kind of manages airflow, and it puts it through a metered set of slats. After it necks it down, puts it through a metered set of slats after putting a separation thing in the middle too. I guess they're just promoting airflow along that path. They restrict it, put it through the slats, and then measure the pressure difference at that point in order to figure out what the amount of airflow is going through. Really kind of weird, isn't it? I wonder what that plastic part is all about. We can't really get to it. This whole thing is like held together with caulk. I mean, maybe I can get a screwdriver in there. Let's find out. Let's find out if I can get a screwdriver in here in order to pry the two sections apart. This is where I send a screwdriver so far into my hand that Twitch bans me. I don't know. This stuff isn't quite... It's not quite silicon caulk. It's a little bit harder than that. Yeah, I'm not getting in there. I think it might be... It might actually be plastic welded. What do you mean use case? This is a CPAP machine. It is now very much not a CPAP machine. Jeez, this plastic is really fucking with my camera. Camera, can we take it easy here on the brightness? Jesus. I'm gonna keep my grody finger in the way just so that I can see. So this stuff looks like silicon caulk, but it's not. It doesn't, it's actually kind of hard. I don't know what this hard caulk is all about, but I'm gonna keep saying it. It might be what this plastic does when it's plastic welded. It might clear up quite a bit. I wanted to get at this. See those? It looks like a heat sink. It's so weird. I think it's pretty cool though. It's like a metered set of slats. I guess to have a fixed amount of volume so that the pressure can build up properly. And you can get a good reading across it. It's cool tech. I think it's cool. All right. Anyway, that's about it for me. I think we've run out of stuff. I've extracted the sensors I wanted. It's going to take us more than an hour to get those running on the Arduino, and I got to kind of end a little bit early today. Next week, on Tuesday, maybe for airflow obstruction. You think what, to like catch stuff before it gets through? Because if the hose on this end is pinched, there's a pressure transducer here. I think this is just for volume. But yeah, it hits there and it gains a little bit of turbulence as it goes through the slats, and maybe that turbulence is what causes the difference in pressure a little bit there, and that's how you meter your airflow. Something like that. Apparently these got recalled because this foam would disintegrate, and then those little pieces of foam would make their way into your body. Beautiful. Beautiful job, Philips. They wanted it to be quiet, so they put foam inside of this thing. Go figure. But yeah, what happens is air gets sucked in through the filter. It gets a humidity and temperature measurement with just this little like slat inserted into the airflow. So airflow comes up and across the little surface mount I2C sensor from over there. it gets metered by going through a set of slats here. A little bit of turbulence on one side, you'll get higher pressure. Well, I guess it's sucking it through, so I don't know if that's exactly how it works. You'll get a difference in pressure between here, so you can get a volume measurement on a known fixed volume that it's flowing through. More foam to keep it quiet. Up into the impeller of a 3-phase, very controllable, quiet squirrel cage motor. Looks like an organ. Where it then gets measured for pressure again against atmosphere. So this is it measuring against itself. That's a dual sensor. One of them measures the pressure on the outlet of the pump, and then the other one measures atmospheric pressure. Then you go into the chamber where it is exposed. It basically flows around a reservoir of distilled water that is heated from below. That heated distilled water adds moisture to the air. There's no moisture sensors on this. You have a humidity sensor on the inlet. So humidity and temperature, and then you can know what kind of heat you need to add to the water in order to make the air a little bit more moist. So it does that job for you. Then it fires it all the way down this tube where it can heat the air. So it's got a long heater that goes through the entirety of the tube, where it is then measured again against probably I don't know if it's a heated resistive element, but I don't know if that's the temperature measurement for the outset, probably, because they're not going to do pressure transducing all the way over here, I guess. So that goes all the way out to there, where it is then filtered into your nose, where your nose is then going to filter it, hopefully get all the little chunks of foam out of it, and heat it up in your nasal passage and moisten it in your nasal passage, and then it's ready to go down into the lungs and keep you sleeping instead of frequently waking up due to suffocation. Pretty cool device. It's doing a lot of measurement and metering. It's a health device. They do that. If there is an obstruction in the air pathway, they're going to see an increase in pressure, read it over here, see a drop in flow. There's multiple different sensors that are going to be figuring out what's going on here. Pretty cool device. I'm happy we did this, because I wanted to look at this thing for years now. This thing has been sitting on a shelf. I'm running out of stuff to take apart. You have to start buying toys and stuff. I have to start buying toys again and getting on the Amazon day to get some bullshit, microphones and stuff that we can play with. Also, I mean, as Burn the Subs 2.5 spools up a little bit more, when I can get wood on the wall and then it'll become real, we'll be working on that a little bit more on Fridays too. But I like to take stuff apart. There's only so much stuff in my life until I've taken apart everything that I love, and this stuff doesn't go back together. Some of it does, not this stuff. Anyway, I'm gonna pack the sensors away. We'll play with those on another day. Tuesday I want to do like basics with Arduino. So I guess maybe we'll play with the sensors on Tuesday. That's good. Then I don't need to clean up my desk. Well, I probably should. No, we didn't complete the RC car. I'm pretty sure I know what's up with the RC car. I've got it all in bins on my regular desk, so I'm going to see if I can throw some code at it and get it working. I think what I did is I didn't initialize. There's 2 timing registers that are responsible for the one timer. I think maybe I didn't initialize the other timing register. So it's like, I don't know what's going on. Ugh. I haven't really pinned that down, though. I did a little bit of datasheet reading, but it's only been one day. There's only so much time in the day, guys, and I can't do this permanently. I have to do other stuff. So I'll take a look at it and I'll see if I can solve it or not. I'm really annoyed in that. But we need that perforated board for Tuesday, because then we'll hook up some of these sensors and play with them a little bit and see how they work and what kind of stuff they do. Okay. Anyway, that's it for me for today. I know this is a little bit early. I've been doing 3.5 hours of this. That CPAP machine came apart much more easily than I would have ever imagined, and it was really fun, and I'll just end on a high note. We'll end on a high note, right? I don't want to faff about for another hour. Well, typically I would, but Tomato is doing Space Station 13. Is that something that you guys would be interested in rating? I don't think I'm going to force that on you guys. It's kind of an acquired taste. Space Station 13 is like a mostly text-based game that you can like role play in, and everybody starts on a space station, and is sort of like doing their roles. And there's a couple people in there that are sort of designed to randomly cause trouble. And then eventually things devolve to the point where everybody has to escape on an escape pod, and it just devolves into madness. He's gotten back into that game. It's pretty cool. He has his own little server for it. I was debating on whether or not I wanted to give it a try, but I think not. We're going to stick to electrical engineering for now. Uncle Phil is headed there. Yeah, everybody go follow Uncle Phil down the hall to Tomato. Among Us with extra steps. Among Us with like a shit ton of capability to it. Like there's some transformative rounds in that. There was one where I believe a couple people went off and like hunted aliens out of nowhere. Like there are like plot modules that can plug into the rest of it. So it's much more comprehensive than Among Us, but it is somewhat like that. Anyway, if you guys feel like checking it out, go check out Tomato. I'm not going to raid. I'll be back on Tuesday, and we'll figure out what to do from there. Is Djibouti doing art? Oh, no, they're doing Spider-Man Miles Morales, which is a fun game, too. All right, anyway, thank you guys for hanging out. More stuff, more electrical stuff on Tuesday. We're going to have more of a basics day. I'm going to get mad at chat, and then everything will flow, and I'll be able to actually teach you guys some stuff with Arduinos. How to do reverse engineering and hacking devices with Arduinos. That should be pretty fun. I'll see you guys Tuesday. And I had nothing. I got nothing. What is this place?